A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments. Ashwin, kindly write a mail and send it over to me. We'll take it up. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IS. Welcome to another session of geography, where from today we shall be initiating the module of geography. And in our journey for around 24 modules, we shall be covering this particular subject from the very basic, from the very scratch to the requirement of the examination. Now, in this entire journey that we are going to encompass and that we are going to cover, we are going to cover various different facets of geography in general. Now, before anything else, we have to understand and we have to appreciate why is it that UPSC is asking you this particular subject in the examination. I'm sure you yourself would have asked this question to yourself while looking at the previous year questions, that why is it that we who are aiming to become, let's say, an Indian Administrative Service officer or an IFS officer, etc., why is it that we are required to study the subject? So basically, this subject is something which tells you a lot about a particular region, its clothing habits, its feeding habits, the kind of occupation that people end up doing, and also is successfully able to explain many of the geopolitical events of the past. When we talk about history and when we talk about the evolution of history, you will also end up finding that it is deeply ingrained with its impact laid by geography as an area of expertise. Now, as an IS officer, IFS officer, or any officer in the civil services, you are expected to know about your country. You are expected to serve your country in the best possible manner. And geography is an ideal tool for that. And for that, oftentimes, I ask people to think about it. That when you think about the entire history of India, the modern India that we talk about, now that is something which has been crafted significantly with the advent of Europeans in India. But if you think about it, why is it that the Europeans needed to come to India? Why is it that the Europeans went ahead with their colonizing program in the entirety of the tropical regions of the world? Be it the Caribbean islands, be it the African regions, be it Southeast Asia, and so on. So, there, the solution lies in geography. So, that is the role that this subject plays. Any particular area, look at the political setup, look at the international geopolitical relations that any country has. It is deeply ingrained with the geography of that region. When we talk about India expanding its infrastructure in Andaman Nicobar Islands, to, let's say, the occurrence of very frequent natural disasters such as cloudbursts and landslides in the northern part of the country, all of that significantly impacts our day to day lives, isn't it? And that again is geography for you. When we talk about, let's say, in these months, prices of fruit, grains, they significantly begin to escalate. Why is that? Again, agriculture is the portion of geography that determines it all. So that is where this particular subject is something which drives the socio-political setup, the economic realities, as well as the way of living that a civilization or a culture ends up adopting. That is the level of critical thinking that we are going to aim to achieve in our due process of around 24 modules. Now, today, we are going to have a brief insight about what this subject is about. What is it that you are required to study in this particular subject? Is there any particular approach that you need to develop when you are attacking this particular area or when you are preparing for the subject of geography? And also the module distribution, the books that you need to refer to. Okay, which are the books which are absolutely necessary, which are the books not very much required, how to approach the atlas. These are the few of the basic things that we are going to be looking into. In the meanwhile, I'll try to take up as many questions of yours as possible. Our subject matter experts will be at it. But then, at the end of every chunk of discussion that we hold, I will be taking up few of the questions in the meanwhile. I would urge all of you to have that minimum decorum in terms of patience, that have some amount of patience in case your questions are not being answered to immediately. Don't worry about it. We'll be taking it up at the end of the session as well. Okay? Now, here, when we initiate the discussion, first of all, we talk about the importance of geography from the perspective of the examination. Because I'm sure, regardless of whatever our backgrounds might be, if we are sitting in this session and if we are attending this session, we have only one goal, and that is to clear this examination. I'm sure our goal is not to be the greatest geographers that India has ever witnessed. I'm sure our goal is not to become the greatest climatologists that the world has ever produced. Our goal right now is to clear this examination. Now, there are various different perspectives to look at the aspect of preparation. That many of the times you will find that the candidates, when they initiate the preparation initially, few of them you will see that the last year's question paper, for example, those of you initiating the preparation this year, amongst your friends and your colleagues, you will find many of them would have picked up this year's prelims paper and would base their entire preparation only about that and around that. Now, in this case, what happens is UPSC changes its pattern almost every other year in terms of the areas that it is focusing upon, in terms of the types of questions that it is asking. So, next year, again, you will be held in a kind of a lurch and you will be forced to try again and again and again. So, here, what we are going to do is we are going to understand in this entire 24 modules, we are going to understand what are the key areas that UPSC does attack. Now, if suppose UPSC focuses upon a particular unit in climatology, let's suppose one or the other question every other time is being asked from that particular unit. So we shall be basically endeavoring to understand that particular unit to such a depth, aided by the various different previous year questions, etc., so that any new question which can be created from that area would be easily solvable. Okay. And I'll also tell you what this entire discussion that we are going to have in the class, what are the content materials that are going to be covered in that, and then what is it that you need to be doing in order to ensure the completion of syllabus in time. So first of all, why is this subject important for your exam? So you have the direct questions in prelims, the direct questions. Now, roughly around 15 questions are asked in the prelims directly. Okay. I'll also be telling you about the distribution, about the type of questions, that which are the areas that the questions primarily focus upon. That is also something that I would be stressing upon in our due course. But generally, this 15 questions that you see is a mixture of the area of the static portion and then the dynamic, that is the current affairs related. Around 8 to 10 you get directly from the static portion, and around 4 to 5 is the dynamic portion, that is current affairs. Okay. Now, if you have a basic level of preparation, that we are going to uphold the level of discussion in the class, and I'm sure I will have the dutiful participation from you guys as well in order to maintain that level of discussion. So after that point of time, I'm sure out of this 8 to 10, easily you would be able to solve close to around 6 to 7 out of this and 2 to 3 out of this. So out of 15, easily you would be able to score somewhere around 10 to 11 questions easily. Okay, and then depending upon what is your coverage and how regular with you are with newspaper reading and the portion of current affairs, that will be able to determine to what extent you can go. But please understand, in a scenario where the cutoff is revolving, the prelims cutoff is revolving around 85 to 90 marks, and chances are that this year's cutoff is going to be somewhere around 82 marks that UPSC is going to declare maybe next year. So understand, in that scenario, one subject offers you 20 marks directly. And this is considered to be amongst the tougher subjects. Ask the candidates, ask your seniors, ask your colleagues. They would be telling you that this is one of the difficult subjects that they approach. But that is what we are going to simplify in our journey. And at the end of these 24 modules, I'm sure difficulty is not a word that you will associate with this subject. But then, not only for your prelims, when it comes to the mains exam. So here, subjective questions, they appear in GS paper 1. And in GS paper 1, what is the total weightage of GS paper 1? Let me see if we are aware. The total weightage? Good. At least we are aware of this. So out of the total weightage, that is 250 marks, you have around 105 plus marks directly from geography. And that is not a small chunk. That is a significant chunk. And let me assure you, and you can verify it with the help of the previous year questions as well. But basically, but basically, as you hold the discussion and as we discuss along with the real examples about what is going on across the world, how geography is driving the various different migration patterns, etc., that we see even across our country, the various problems that we encounter in our cities, all those factors as we discuss, I will always be welcoming your ideas as well, because please understand, this entire 24 modules, that journey will try to have a kind of a two-way communication. And those of you who have attended the session earlier would also adhere to the fact that quite often times it is the reception of various different ideas which helps you to look at the larger perspective. So that is something that we are going to focus upon. And eventually, from the PPTs, from the preparation that we are going to address along with current affairs, out of this 105 marks, let me tell you, around 85 to 90 marks is something that you can easily approach. Okay, then rest of it depends well upon the level of content that you have indicated, the amount of presentation that you have basically excelled in, your time management, etc. But even if you have got the ability to approach around 90 marks easily out of the PPT and out of our discussion and current affairs, that is more than sufficient to give you an edge in GS paper 1, which is otherwise a low scoring area. So in this, out of 105 plus, around 85 to 90 marks. Okay, so that is where we will be working upon. Our entire focus is going to revolve around these two portions, primarily around the mains preparation, and also in the meanwhile addressing the areas that UPSC has been asking in the prelims. Now, but this is not the only role played by the subject of geography in your preparation. As you would be aware, that for your preparation and in your journey, you are, as a candidate, are also expected to have a proficiency for environment and ecology, isn't it? Environment and ecology. So here, When we talk about environment and ecology, your understanding of the climatic conditions in an area, your understanding of the geophysical landscape of any particular region, and also that gives you an overall idea about how life would be influenced in that area. For example, if there is an extraordinary cold weather condition in an area, why is it so? If you are able to explain that, obviously naturally you will also be able to come to the conclusion why certain animals are not to be found in certain area, and so on. Even this year, when few of our candidates and few of the people that we have had the good fortune of mentoring, when they went for interviews for forest services, I am sure you would be aware that forest services interviews were held only around last month. Now even in those interviews, you had the interview board asking so many questions directly from the area of geography, that many of them got an easy time or an easy pass because of that. So, this is a subject which is going to help you even as far as the interview process. And environment ecology, disaster management. For example, what do we study in disaster management? I've seen many of the candidates holding that out as a subject, that this is a subject I have not particularly finished for mains examination, so I'm a bit nervous. But what is it that you study in disaster management? Handling of the various different types of disasters, from earthquakes to urban fires to cloud bursts to landslides to even cyclones and storm surges. Now, all these features we study in detail in this subject of geography. That why these events happen. Let me cite you an example. When we talk about an earthquake, now when earthquake strikes, we have seen recently in the case of Turkey and Syria that when an earthquake struck, and if it is a powerful earthquake, it has got the potential to cause large scale destruction, large scale devastation. That is what is a disaster, isn't it? But once you are able to identify that whenever an earthquake occurs, 1 minute or 30 seconds prior to the main strike, you get a kind of a shaking of the earth, which is not perceivable by all of us. So you can always end up installing certain amount of alarms, certain types of devices as well, early warning systems. Similarly, we have all seen the very devastating and in fact frightful scenarios and pictures and videos in front of us about what happened due to intense amount of cloudburst rainfall in Himachal Pradesh. How is it that Yamuna started overflowing its marks? How is it that Assam again this year got flooded, even though the news media didn't pick it up? So here we study why these rivers they get flooded year after year. And why is it that despite billions of dollars or rupees that we are ending up spending in management of disasters, why is it that we don't have the foresight to stop those disasters? Isn't it that what is required for you to express in the subject of disaster management? That is entirely what is expected. So those areas will also be addressed quite significantly. Now, here, before I go into the nitty gritties of the discussion, I hope you understand the importance of this particular subject. Now, classification. What is it that we are going to cover in this particular module? Now, here, for the first time here, what we are trying to do this time is we are going to have the entire subject distributed in 25 modules rather than 24. So you will have 24 modules for GS plus one module at the end. One module at the end. And this will be for your doubt clearing. Okay? Any type of doubts that you have throughout the discussion, it is absolutely possible that while we are discussing geomorphology, at that point of time, You might not have ingrained any kind of doubt. And slowly and steadily, as you would have entered into the later portions of geography, you might have developed a doubt while revising. So, any doubts that you have, any kind of difficulty in understanding the subject that you have, now, because many of the candidates have been frequently requesting us that please provide a separate doubt clearing session in itself. So, that is something that we are going to address this time. So 24 modules is which in which we will be covering the syllabus, and one separate module at the end will be precisely only for doubt clearing. Okay? Now, here in these 24 modules, what is the distribution going to appear like? So first of all, I'll lay the roadmap in front of you so that you also should have a clear cut idea about how this preparation journey is going to span by. And I want you to be careful enough, okay, so that you should also have the foresightedness about what is going to follow after this particular module. I don't want any of the student here to be so very blindsided that, okay, if today I'm teaching geomorphology, I'll study geomorphology. If tomorrow I'll start Indian geography, I'll start with Indian geography. No, you should have that kind of a foresightedness, that in which portion of the syllabus are we stressing significantly, because we are going to stress very significantly on the concept clearing physical portion of geography and Indian portion of geography, which more of us and almost all of us are well versed with. That is something where we shall be trying to frame a kind of a memory aid, a kind of a concept layering there also. But then it will be much more aided by the portion of current affairs. So you should be aware of that. So, first of all, we shall be talking about geomorphology. Now, this geomorphology is going to span for first 5 modules. Now, what is geomorphology? The various different types of shapes, features, variations, topographical formations that we see across the earth's surface, the land that we live on. Okay, so studying that land, what are the various forces, the types of rocks, how is it that the continents they get built, what is it that is comprised underneath the oceans, at the base of the oceans, what is it, or why is it that volcanic eruptions occur, why is it that earthquakes occur. So those are the areas that we are going to primarily address here. So here we are going to study about the basics first of all today, in which we are going to talk about latitude and longitude, then origin of earth, then after that rocks, then continents and oceans, and here we are going to study about the theories: continental drift theory, plate tectonic theory, seafloor spreading theory, convection current theory, all those various theories we are going to address here. Then earthquakes and landforms and volcanoes, and then erosional and depositional landforms. Now that is geomorphology. Here the concept layering is required only in certain areas, in certain basic areas, for example, origin of earth, then these theories. This is where you need to understand the concept. Once you have understood these two basic concepts, rest of the geomorphology automatically follows. That is the beauty of this particular module. Then after that, we will be coming over to the most important portion of geography as far as understanding of concepts and the variation in types of questions are concerned. And that is going to be climatology. Now, climatology we are going to cover from module 6 to module 12. That is going to be climatology. And this is going to include the entirety of the details about right from the formation of atmosphere, how is it that the atmosphere got created, what are the features associated with the atmosphere, when we talk about troposphere, stratosphere, ozone layer, greenhouse gas, global warming. Now, all those facets of it, urban heat island. So, atmosphere, heating, pressure, wind movement, air circulation, cyclones, all of those factors, El Nino, jet streams, we are going to study in the portion of climatology. And all that we are going to study, why? I'll let you know. So, from atmosphere and temperature, that is where we are going to initiate the discussion with, and then pressure and winds, clouds and rain, then cyclones, jet streams, etc. So, all this we are going to study in order to understand Indian monsoon. That is going to be one of the most important topics in your coverage of geography, because this is where many of the questions are asked from. Then we'll come to oceanography, about the ocean currents, etc. Okay, and this will be module 13 to 15. Ocean currents, formation and behavior of tides, ocean bottom, then the oceanic temperature, pressure, salinity conditions, we are going to cover there. Then, after that, from 16 to 23, we are going to cover Indian geography in detail. About the formation of the Indian subcontinent itself. That is how deep we will go. Okay? From around module 16 to module 23. So, this is what we are going to study in that. And after that, one module will be for mapping. So, 24th module will be for mapping. Okay. And then 25th class at the end shall be the module for doubts. So, this is going to be the framework, the skeleton of our entirety of the coverage of these modules. So, this particular portion, geomorphology, climatology, and oceanography, together taken as physical geography, is going to be stressed upon much more. That is where we are going to spend as much time as possible to ensure that there are no doubts which prevail, because once that physical portion of geography is clear, rest of the subject is something that is very easily understandable. Now, coming to the material list and the materials or the book list that is required. Now, let me be very clear here. as a as an aspirant for civil services, as a serious contender for this examination, I would advise you to keep the number of books that you are referring to the basic minimum. Okay, please keep the number of books that you are referring to the minimum. Ideally, which is the book that you should refer for this examination is the NCRT. NCRT is more than sufficient for your preparation. Now, which NCRT? That is the prime question that the candidates have. Which NCRT are you talking about? So, ideally, 11th and 12th. Okay. Okay, I have a question from the same question from Neha Venmati Lakshmi, and that is about world geography. So, please understand that when we talk about world geography, what is it that we are concerned about? The various physical characteristics present across the world, the various different types of physical features, climatic conditions present across the world, the various different types of oceanic water bodies, ocean currents, etc., present across the world, and also in terms of mineral deposits, isn't it? Now, in the portion of physical geography, we are going to cover the entirety of the world. As we cover the portion of, let's say, plate tectonics, or as we cover the portion of earthquakes and volcanoes, we shall be looking at the areas, be it in South America, North America, Asia, Africa, Europe, Australia, anywhere. Why is it that an earthquake or a volcano can occur there? So that will give you enough idea about the portion of world geography. Okay, so while we are carrying out the portion of physical geography, just ensure that any new place that you hear that you are not aware of, open up the atlas after the end of the session and do look at which area has been talked about. That will be more than sufficient. And about the mineral distribution across the world, that is something we will be doing anyways in the mapping portion, where we shall be taking up various different continents at one go, and we shall be talking about the mineral distribution and the features of those particular continents along with it. Okay, I hope that is understood. Now, here, human geography and economic geography, we are going to cover in the portion of Indian geography itself. Okay, so human economic geography. So, what the problem here is that many of us, we know about these classifications, but we don't know what is included in human and economic geography. So, Garvit and Kajal, are we aware about what is required to be studied in human and economic geography? Any idea? Okay. So that is economic geography, Garvit. So in the portion of Indian geography, we are going to cover about the even the portion of biogeography. Before any of you ask it separately, we are going to cover even the portion of biogeography there, about forest, soil distribution. We are also going to talk about agriculture, minerals and industries, population, settlement, transport, factors related to location of industries. All those factors we are going to talk about. Okay. Now, here, coming back to the NCRTs. So, here, when we talk about the NCRTs, that is more than sufficient for your preparation. More than sufficient. Now, ideally, 11th and 12th NCRT, you have many of those books. So, those books will be more than sufficient. Now, in case, even though that should not be the case, but let's suppose we are not very comfortable with 11th and 12th geography NCRT. In that case, pick up the NCRTs of 7th, 8th, 9th standard without any ego and start studying from that itself. NCRT is easily available. It is available for free online. You can always take a look into that. So, if not understood, then 6th to 10th NCRT. Okay. Otherwise, the portion of human, economic, Indian geography in general, and also the physical portion of geography will be ably covered in your 11th and 12th NCRT. So kindly focus upon these NCRTs. Okay. Now, if you have the Byju's book, you can basically cover that. In case there is some issue without the about the delivery of the Byju's book, don't let your preparation get hampered by that. It would be an absolute injustice in case your preparation is getting hampered. So please pick up the NCRTs, or you can pick up these videos itself. The class sessions in itself, we are going to cover the portion of the NCRTs. I'm sure few of you would be having the tablet videos as well. So those tablet videos also you can cover. They are more than sufficient in terms of your syllabus coverage. Okay. Now, then comes the role played by Atlas. Atlas is going to be your best friend in your entire preparation of civil services for the subject of geography. Now, our way or our approach to Atlas needs to change. How we end up approaching the Atlas in general is that we take a list of names, we start locating it, and we feel our work is done. That is not how you study the Atlas, or not at all how you should approach the Atlas. Ideally, let's suppose we are talking about any particular place, formation of fold mountain or rockies in North America. Now, ideally, once you study that in the class, your effort, your endeavor should be that immediately after the class, open up the atlas, explore where North America is, first of all, explore where the Rockies are, try to look at the areas around you. When you open up the newspaper early in the morning, do look at the various different regions. Okay, look at the various different areas, various different regions, for example, and any place that you are not familiar with, please do not hesitate that I will take a look at this particular location sometime later. No, immediately you have to open up the atlas. So atlas has to be linked with the portion of current affairs. If you look at the questions asked by UPSC even this year also, UPSC did ask questions about, for example, it did ask about the location of or the nations surrounding Ukraine, for example. That was very much associated with the portion of current affairs. Also, it asked about the mineral distribution in Africa. That was also related to portion of current affairs. So newspaper, as soon as you start linking with current affairs, it becomes easier. Okay. So explorative linked with current affairs. Okay, Mainam, why we have to read NCRT, sir, if you are teaching in the classes? See, if whatever has been taught in the classes is ably retained, there is no issue while revising it as well. So you don't need to study those books, but you need to be able to understand all of those things in the classes. Maybe after 2 months' time or 5 months' time, when you want to revise again, at that point of time, if you want a textbook, it is only for those conditions that I am suggesting the NCRTs. Otherwise, if you are thorough enough, regular enough with the classes, you are following it regularly, you can skip those. You can revise with the classes itself. Okay. Should we read NCRT according book or according to class? According to the sessions, you can study as and when the sessions are covered accordingly. Okay. Which book should I refer for economic geography and Indian geography? NCRT, class 12th, Shama. Okay. Chandrasekhar, don't worry. Just start in that case. If you are requiring a book, start with the NCRT. And for NCRT, I had another question that what is the Shoaib? That which is the website where we find free copy. Even at NCRT, the official website, you get the free copy. Okay. Any atlas which is available should be sufficient, because atlas not only helps you understand this subject in a better way, it also helps you relate it with the areas in discussion and the portions of IR, international relations, the questions that you see in IR, that also will be much easily understood. For example, Armenia and Azerbaijan, they have been quarreling for some time now. Why have they been quarreling? Because of a disputed territory in between them, that is Nagorno Karabakh, and that is an oil rich area. Now, if you start following all the oil rich regions of the world that UPSC might ask them, you will end up spending endless amount of hours and you will not get any marks as well. But if you follow the portion of current affairs, look at the atlas, cross reference it with the atlas, immediately you will find that Nagorno Karabakh has been in discussion. UPSC has asked that particular question this year in the prelims examination. So that is how atlas has to be used. Okay. So NCRTs are the main book. Newspaper has to be read on a daily basis. There are no two ways around it. Newspaper reading is an absolute must. Okay. Should we need to buy another book? Absolutely not. Many of you would have had the urge, or your friends or your colleagues would have told you about the books such as G.C. Leong, Majid Hussain. Okay. Now, These are the books which would be suggested by many of your friends, your seniors, etc. Let me have some clarification. GC Leong is only there for the portion of physical geography, and even for the portion of physical geography, it is not required to be studied because this has not been written keeping UPSC in mind. Please understand that. Only one particular chapter about climatic classification of the world, that is something which is given well in GC Leong, but for that you don't need to read the entire book. Okay. Now about Majid Hussain. Now, Majid Hussain is oftentimes recommended for the portion of Indian geography by many of your seniors, etc. If you want to read that book, you are free to do so. But again, I would suggest keep the number of reference materials to the minimum, because it is always advisable to read the same book 10 times than being able to read 10 different books which you are able to cover only once. So, always advisable to read the same book again and again and again. So, and even I will go to the extent where I will point out that in the last 10 years, if you pick up UPSC question paper, leave alone what your friends are doing and what the world is saying around you. If you pick up the UPSC question paper for the last 10 years, you won't find a single question which has been given here and has not been given in the NCRT. So, if the work can be done by the basic book, why to complicate it? That is the concept here. Okay. So, try to keep it to the minimum. Okay. Now, then after that, here Kashiba, even that is sufficient. Here, this is going to be our module progression that we have already talked about. From geomorphology, we are going to proceed to climatology, to oceanography, and a compilation requirement of all of those is going to be required in the portion of Indian geography. Now, these are the areas through which we are going to cover the world. Okay. This is how we are going to cover the world on a day to day basis. Now, what is the lecture going to comprise of? So, lecture that we are going to have in the session on a day to day basis, that is not going to follow a particular textbook, that what you have said is not given in the textbook, or what you have said is not there. So, the lecture is going to comprise of the compilations from various different sources, from books like Stroller to various different books which are available. So, the latest research papers which are being submitted, all of those we are going to summarize in these lectures, including the websites of Meteorological Department of India, NASA, and so on. So, that is going to be the compilation and the deliverance in these lectures. You should be aware of that. Okay. And after the lectures, you can cover the same portion either from the tablet if you have the tablet, or from the portion of the annotations of the PPT, along with the additional reading materials that are going to be supplied to you. Overall, the approach that we are going to follow is going to be a visualistic representation of the concepts, because for a subject like geography, it is better and always recommended to have that visualistic impression of any event, any geomorphological feature in your mind first. Once you develop that, then recalling that in the time of requirement of the examination becomes very easy. So that is going to be our approach. Okay. So with that, we initiate now the discussion for the subject. Before that, we will take a couple of questions. Kavya, current affairs for past 2 years or 1 year. 1 year is sufficient. Human geography, Bhagya, we have to study, but mostly associated with the area of current affairs, the questions that are asked from that. Uh, the entire course Veena is going to comprise, will be completed by 26th of August for geography. Uh, Varun, despite scoring good marks in geography mocks, I'm not getting confidence. Revise, my dear friend, revise. And note making. Okay. So when we talk about note making here, you can make a kind of a running note with the class itself, but that should not be at the cost of missing out any of the concepts being laid out in the class. Okay, it should not be that you are so busy writing notes that you have missed out whatever has been talked about or taught in the class. That should not be the case. Other than that, you can go for a running note. What I would advise you to do is, in case you are trying to make a running note, first of all, keep an A4 sheet paper along with you. Any important topic or the major topic that we are initiating, any terms that you come across that you are not aware of, draw the visualistic diagram that we have represented in the class in the PPT, or write one sentence about it at max. This is your preliminary note, running note of the class. After the session is over, with the help of the annotations of the PPT, with the help of the additional reading materials that will be supplied to you, where you will have the detailed definitions, detailed write ups for the majority of the types of questions of that area. So, with that, you can summarize your understanding of the class and then funnel it into the concise notes. That will be your revision notes. Okay, so if you are going for note making, ideally take note of only the important points that you don't find while discussion in the PPT or the annotations, or that you feel will be helpful in making you recall the concepts covered in the class. Okay, yes, Dhanraj, that is sufficient. Aziz, is the PPT sufficient for geography along with the portion of current affairs? Yes. Okay. Manipur incident won't be covered in the portion of current affairs. No. It is something that you will study and you would have studied anyways in the portion of the internal security. But let me very well tell you, with a level of assurity, knowing the type of questions that UPSC asks, UPSC never asks these kinds of questions. Okay. Shiva, geography in only in GS paper 1. The portion of agriculture that we are going to cover here is going to help you in GS paper 3 as well. Sarita, you can try to start newspaper as early as possible. See, newspaper reading is the moment all of you understand one basic fact, and that is the fact of preparation. Understand one basic fact. Any of your seniors or any of your mentors, if they are telling you for newspaper reading, that is not for the point of view of current affairs. Current affairs you will gain by monthly magazine here, there, etc. But that ability to abridge various different portions and concepts together, the ability to weave a story around how, let's suppose, a particular region's geographical location ends up determining the calamities and disasters, and that ends up determining the political situation, that ends up determining the migration patterns of that area. That ability to look at the larger picture and ability to portray that in your answer, that will be gained only by newspaper reading. Otherwise, you will have bits and fragments of every piece of information, but you will not be able to write a good answer or narrate a good answer in front of the interview board. So if you want to have that better preparation in itself, better understanding of the various subjects as well, start reading the newspaper. Okay. Now, what is social economic geography mentioned in prelims? Social economic, so Teja, that is the portion of when you talk about the industries, when you talk about minerals, agriculture, those are the areas, and also about the aspect of human population, settlement, etc. That is basically about the portion of geography. Okay, after the syllabus of geography, yeah, Karan, that is correct. What about answer writing? Shantanu, should we start writing answers as the module progresses or once it is completed? As we start discussing the PYQs, you can start writing the answers for the PYQs along with that. Okay, if you are comfortable enough. Is editorial reading necessary? Mustaba, absolutely yes. And disaster management is important for disaster management is not asked in GS paper 1, my dear friend. Disaster management is something that you find in paper 3, but your understanding of geography is going to help you even in that. Okay, Roshan, as early as possible. Will the Amandeep, will the various agricultural practices of the world come in the exam? We will cover that. Generally, it is not frequently asked, but we will cover that. Okay. And why Manipur violence? Manipur violence, about the various issues going on, you will cover in internal security in detail. Don't worry. NCRTs are very much readable, Rakesh. Mitisha, geography as an optional subject is also attractive enough. If you have interest in the subject primarily, you should not hesitate to take that subject, because this subject has got the ability to reward you more than 300 marks, provided you are good at it. And anyways, any optional that you choose, your aim has to be, if you have to be successful and not a mere competitor, your aim has to be to figure out in the top 10 of that optional. And the top 5 rankers, or top 5 to 10 rankers in geography optional, they end up scoring more than 300, or somewhere around 280 to 300. So if you have interest, you can go for it. Okay. And Chandrasekhar, you should go ahead with the detailed content as well. Lakshmi, I'm a beginner. What strategy? So, all those who are beginners as of now, cover the portion that is covered in the class dutifully on a daily basis. Just ensure that, let's suppose today the geography classes have begun. For the first 5 days, we are going to take it very slow. In fact, for the first 10 days, we are going to take it a bit slow, just to aid in your understanding, because I understand many of you would have not read the subject to such a deeper extent. So we'll take it slow. So let's say on a daily basis, we cover some portion, cover that after the class. Okay, with the help of the additional reading materials, revise it. After Friday, spend some time in revising everything that has been covered in the week. Okay, wherever possible, make your own notes about it, and you will get 20 questions, objective questions to practice on a Saturday, to gauge your level of understanding. That should be your parameter. Whichever area you have committed mistake, revise it immediately. Do that again the next week. But the next Saturday, you have to revise the 10 days which have been covered. If you follow just this basic simple procedure for the next 1 month, let me assure you that by 26th of August, your understanding of geography will be to such an extent that normal mains type questions won't scare you at all, and you will be spending energy on how to present in a beautiful manner. That is the level of assurance that I can guarantee. Okay. If there is no map in any geography answer, will it negatively impact? It won't negatively impact you if you don't have maps, but then if someone else has depicted the map, they will be positively impacted. So they will get more marks. Eventually, it is not about whether you score 40% or 50%, whether you are scoring more than your competition or not. That is the entire thing. Okay. Does UPSC exam give map pointing? Sandeep, in GS, no. In optional, yes. In general studies, you come across a couple of questions associated with current affairs, where you, for example, this year, there was a question about Nagorno Karabakh. There was a question about the countries bordering Ukraine because of Russia-Ukraine war, and so on. Okay. Sakshi, I'm a college student, 3 hours class plus making notes. How to manage time? See, current affairs, you have missed out, Sakshi. So, at this point of time, in one day, just study the portion cover in the class and revise it on a daily basis along with current affairs. Take it slow. If you don't have time, take it slow, but this is a minimum thing that you have to cover. Okay. Diagram will always give you a better representation in front of the evaluator as well. Deepshika. I'm not a good map maker. Does it impact in mains exam marks? No. Even a rough map is more than sufficient. How do we check our answer writing? Send it over to us at IS Live. We'll get it checked. Okay. Which newspaper is sufficient? Any newspaper is sufficient. Do you have to make notes of newspaper? No. Take it up from the basic current affair magazines that you have. That will be sufficient. Okay. Okay. So with that, we will initiate the discussion of this particular subject. And slowly and steadily, we will be proceeding ahead into the portion of geomorphology and into the depth of geography. Today is going to be the very initiation. So, when we talk about geography as a subject, this is a particular subject which has always attracted a lot of attention amongst the general population for a long, very, very long time, since time immemorial. In fact, all of us, we have studied about Alexander. If not studied about it, at least we have heard about Alexander, haven't we? Now, Alexander, wherever he went for his conquests, he would always carry a cartographer along with him. Now, who is a cartographer? The person who can depict everything in a precise map. So, that is a cartographer. So, a cartographer used to accompany Alexander everywhere. Alexander had the basic aim or the goal or mission to conquer the world. And how would that be possible if you don't have the map of the world? That is where, even when he came up till the banks of River Indus, it is said that he sent his cartographer along the River Indus to find the sea and the way back to Greece. Now, the Greeks, in fact, or why only restrict our discussion to the ancient Greeks? In fact, in general, the human tendency along any civilizational journey that you will look at, you'll find one basic parameter. Once people have had an assurance about their own living, that we are not going to die, we are going to survive, we have food source, we have access to food, we know and understand our climate significantly and fairly well, people have always wandered around trying to explore more. And always, even if you take a look at the ancient cave paintings, you will find endless amount of paintings of the sky, of the sun, the moon, and the stars. Why is that? Because we humans have always been curious. Where are we? In that entire setup of these stars, the suns, and the moons, where are we placed? What is our position? And what is our role in that entirety of the universe? Now, in the initial stages, mankind was pretty much convinced that we all live in the sphere, inside a sphere, because the sky would look spherical. Obviously, our understanding was very much limited. So you cannot blame people of those days that they did not have a proper idea. Slowly and steadily, as we started observing the stars, the moon, the sun, now for a common individual, what they would look at as they woke up in the morning is that the sun would rise and the sun would set. The sun would rise again in the east, set in the west. Again, it would rise in the east, again set in the west. The stars also they would observe, that would move across the sky. So that gave an idea, and that idea was that we live on a planet that is Earth, and we are the center of the universe. From the sun to the moon to the stars, the sky, everything is moving around us. That is what we see when we wake up, that is what we see when we go to sleep. So that earlier model of universe, where we did not even have a clue what is a solar system, what is a universe, let's say, that earliest model where one thought of planet Earth to be the center of the universe, that is referred to as the geocentric model. The geocentric model. And this basic model was that we are at the center of the universe. The entire universe moves around us. But obviously, in the initial days, the understanding was also very much limited. You had very limited ways by which you could explore the world. Now, this prevailed for a very long time. Then, slowly and steadily, when we had a better understanding of the world and the scenario around us, then people found out that okay, the sun is consistent, Earth moves around the sun, and the various different planets, they also move around the sun. Now, in that situation, the understanding changed. The understanding changed to a condition where everybody thought that sun is the center of the entirety of the universe and everything moves around the sun. Now, even that was wrong. As wrong as a geocentric model, even that model of sun being the center, that was also wrong. But it was adopted, it was understood, it was followed for few centuries. And that was what was referred to as the heliocentric model. Understand the pattern here. Geocentric means geo, that is Earth. Earth as the center of the universe. Now that was replaced by heliocentric. Helios means sun, sun being the center of the universe. But even at this stage, our understanding about what the stars are composed of, what the sun is actually comprised of, how is it that sun keeps on producing this much energy, all this understanding was very much limited. So heliocentric model also prevailed. But then, slowly and steadily, with the development of the telescope, development of Newton's law of gravitation, we had a better understanding about the behavior of the celestial objects. And that is when, from the 1750s, model for the origin of universe that started coming in. So first of all, you had in 1755, roughly around that point of time, you had the theory of origin of universe provided by Kant. Heliocentric, Deepak, is where sun is considered to be the center of the universe. That is heliocentric. Now, as early as in 1755, Kant ended up providing with a, just a moment, yes, Kant ended up providing with a model for the origin of universe. But please understand, our understanding of the universe in itself was very limited in the 1700s. For us, the universe comprised of the sun, the earth, the moon, and few of the planets that we could see. That's it. That is all that our understanding of the universe was. So the theory that Kant provided, also referred to as nebular hypothesis. Now that is something, even though you will cover that in the portion of science and tech, not very much required for your examination, but that for the first time gave people an idea about how the various different planetary systems could have come into existence. It was deeply flawed, it was incorrect, but the level of understanding was much lower. Now this was corrected further in 1790s. 1790s by Laplace. Those of you who would have studied maths or certain branches of engineering, Laplace and the very name would strike terror because of the Laplace theorem that he provided. So, Laplace provided some corrections into the Kant's model for origin of universe. But even up till Laplace, the understanding was very much restricted only to the solar system and not beyond that. Now, almost a century passed. This was provided in around 1796. Almost a century passed, and then later on in the 1900s, again 1900s, they embark upon a phase of discoveries. So in 1900s, first of all, you had one of the American astronomers with the name of Edwin Hubble. Now, simultaneously, theories were being provided. Theories were being provided by Jeffries, by Chamberlain, various different geologists, geographers. They would provide the theories, and scientists rather, and physicists. They would provide the theories about the origin of the universe, but majority of them would be incorrect. Now, in such a backdrop, you had an American astronomer with the name of Edwin Hubble. Now, Edwin Hubble, through his telescope, he observed the sky. And when he observed the sky, over a period of time, he noticed something very peculiar, very unique. He observed that everything that he witnesses in the sky, every object is moving away from each other. What is the meaning of that? So, let me just give you a kind of a visual representation. For suppose, here, let's suppose this is the image of the universe that you gain from the telescope. Now, what Hubble observed, now each of these small things that you are seeing, each of these, by the way, is what? It is a galaxy. I hope we are aware what is a galaxy. So, galaxy is a, what is a galaxy? Let me see if we are aware. Galaxy is something you should be aware of, isn't it? Group of stars, a large group of stars, right? Combination of stars. Yes, millions of stars, bundle of stars, anything. So, a galaxy is a larger subset comprising of millions and billions of stars in that case. Okay. So, all these are basically galaxies, the image that you see in your screen. Now, what Edwin Hubble observed was that, for example, let's suppose take this galaxy and let's suppose we consider this galaxy. Let's consider another one. Now he observed that all of them, they are moving away from each other. Okay, they are not moving towards any other object. It is not as if this is moving towards this one. No, all of them are expanding. Now, all of them are expanding means this will move away, this will move away slowly and steadily, this will move away. All of them are expanding. So he just noticed this much with his telescope. And that is when he provided for the theory of expanding universe. Theory of expanding universe. And this was provided by Edwin Hubble. Remember, the Hubble telescope was the most powerful telescope that mankind had ever built for a very, very long period of time. And it was recently replaced by which telescope? The James Webb telescope. And UPSC, clever that it is, has asked a question from James Webb telescope. So these are the areas which are very predictable in terms of the examination of means and the type of questions that you can expect from that. So just have a kind of a unique preparation and a simple preparation methodology. Naturally, you will be able to expect or predict certain amount of types of questions. Coming back to it, when Edwin Hubble came up with this idea, now this was something that the world became aware of, that everything is moving away. Now people started interpolating it. What do we mean by interpolation? There is something known as extrapolation, there is something known as interpolation. Just to give you the idea, extrapolation is, if let's say today I am not studying at all or I am having a very lax attitude, people can say that if this follows, that person will never clear the examination. That is extrapolation based upon my behavior. Interpolation is, if you look at someone, let's say, who has become an IAS officer, you basically infer that this person might have studied very well at the time of their preparation. That is why they would have secured good rank. That is why IAS. Now, that is interpolation. Now, when he gave the theory of expanding universe, people started interpolating. And you had a couple of scientists, in the physicist rather, you had Lemaitre, Gamow, and so on. Now, these fellows, they did their research and they started working backwards on this statement that if everything is moving away right now, why is it moving away? Randomly, anything would not move away from one another. There must be a force, there must be a push that is pushing everything away. So they asked this basic question, that is, why? Why are they moving away? So the answer to that was, there must be an invisible force pushing them away. Now, when there is an invisible force pushing everything away, what about the scenario when this force would not have been available? Or where does that force come from? So, going back in time, you can imagine that all these objects which are moving away would have been slightly closer. Going further back, it would have been slightly closer. Going further back, maybe a billion years, it would have been closer. Further back, it would have been closer. Further earlier, it would have been closer. Further earlier, everything could have been one ball of mass. So they went back in time and they thought about it, that if now everything is moving away, then it might be possible that at one point of time, these would have been very, very close to each other. So then the question came, when? If not now, when is it that these would have been close to each other? So there also, by interpolation based upon the level of movement, the rate at which objects are moving, people found out, or basically they estimated, that close to around 13.8 billion years back, or close to around 13 to 14 billion years back, maybe everything would have been nothing but a small mass. A small mass which would have consisted of the entire universe. Almost impossible to even imagine. Almost impossible to imagine a small mass consisting of only planet Earth, let alone the scenario where the entire universe would be contained in that small mass. So there lies the answer to the origin of universe. And that is what James Webb Telescope is out there to find. So basically, what Lemaitre and Gamow they postulated, that close to around 13 to 14 billion years ago, that is roughly around 13.8 billion years ago, everything that we see around us, that was comprised into a small mass. And that small mass was named as singularity. Now, that small mass, where did that come from? So there, they basically said it would have been the creation of the previous happenings in the universe. So there, even the Big Bang theory goes vague. But then, around 13.8 billion years ago, this small mass, because it contained so high amount of mass, so much of pressure, its temperature would also have been very high. So this small mass would have simply exploded. And when this exploded, so much amount of energy would have been emitted that particles, they started traveling faster than even the speed of light. Imagine an explosion where a small mass explodes, and the materials included in that mass, they start traveling with such force that the speed is faster than the speed of even light. Now, under these circumstances, materials start behaving differently. They don't follow the normal state of matter that we come across, but materials would have expanded. Now, when suddenly an explosion happens, heat is created, very high temperature, but very soon as the materials they start traveling outwards, what happens to the temperature? Slightly away from the point of explosion, what happens to the temperature? Do you think the temperature starts rising, or do you think the temperature starts dropping? What do you think? Very good. Beautiful. that it starts to cool down, it starts to lose temperature, isn't it? So as the materials they started moving at a very swift pace, it started cooling down. And that is when you had the formation of particles. Now we know that even the electrons, they are not the smallest of the particles. You have quarks as well. But then earlier it was understood that the electrons were the smallest particles. So electrons got created, atoms got created. Now, slowly, when the atoms got created, hydrogen got created. Hydrogen started combining, nuclear fusion started producing energy, and that would attract more atoms, more electrons towards itself, more nuclear fusion. Stars came into existence, multiple different elements came into existence. These elements, they would move around, float around the stars, aided by the star's gravitational pull. And as they would exist in the same region, they would undergo multiple collisions. Planets started getting created. So our sun, which is basically the life provider across planet Earth, our sun is a star, is a simple star in the Milky Way galaxy. And it is not even at the center of the galaxy. Like Milky Way, we have millions and billions of galaxies that we are able to explore. Imagine the universe that we have not even explored yet. Till now, with all the scientific advancements and developments that we have had, it is postulated that we have managed to discover only around 1 to 2% of the universe. Rest of the universe is not even known to us. So that is where the origin of universe is something which is explained by the Big Bang theory. Why the name the Big Bang theory? Because it was that initial explosion, it was that Big Bang which brought everything into existence. But slowly and steadily, as people came to know that there are more various different types and facets of universe that we are not even aware of, various theories have been postulated by the physicists. One of them is the oscillation, the theory of oscillation, the pulsating theory. Now, what that tells us is that every few billion years, there is that kind of explosion where materials they start moving away, planets come into existence, stars come into existence. Slowly over a period of time, all of them will lose their energy, then they will start falling back. Again, they will form that small mass. Again it will explode, again universe gets created, again everything gets destroyed into the single mass. So that is the various different theories that have been talked about, and that is going to be relevant only for your portion of science and tech, that you should be aware of. For the portion of geography, if you are aware of the Big Bang theory, more than sufficient. Now, this is the artistic representation. Obviously nobody can give you an idea about what happened during Big Bang. The James Webb telescope is bringing you various images which tells you about how the galaxies would have been around 10 billion years back, etc. I hope we are aware that the age of the universe that we have managed to calculate or estimate is close to around 13.8 or 13.5 billion years old. The age of our solar system, however, is much less. The age of solar system, the age of planet Earth, is only around 4.5 billion years old. Okay, so the sun, planet Earth, everything got created much later on, much later. Okay, so again, something that we are going to study, something that you won't find in the books about the about your in your reference books about the formation of planet Earth. That is something we are going to study. But before that, a brief insight about the Big Bang theory. So it was born out of the observation that other galaxies are moving away from our own, at a great speed in all different directions, as if they had all been propelled by an ancient explosive force. So this was observed by Edwin Hubble as he postulated theory of expanding universe. Okay, that theory of expanding universe was very essential in the postulation of the entirety of the Big Bang theory itself, because that helped people like Lemaitre and Gamow to be able to infer what might have happened earlier. So, around 13.7 billion years ago, everything in the entire universe was condensed into an infinitesimally small singularity, a point of infinite denseness and heat, which means everything that you see around, it was contained in a single mass. And that single mass was referred to as singularity. Suddenly, because of very high pressure, very high temperature, an explosive expansion began, ballooning our universe outwards faster than the speed of light. This is the transition. So, initially, at the point of Big Bang, when the event took place, so the temperature was very, very high. Observe how in 10 to minus 43 seconds, imagine how small a time window are we talking about. 10 to the power minus 43 seconds. At that point of time, temperature was around 10 to the power 32 degrees. Then, in 10 to the minus 34 second, temperature reduced by 10 to the power 27 degrees. And imagine that in 1 second since the Big Bang, the temperature came down to around 10 to the power 10 degrees. So as the objects were moving away, things were cooling down. Then came around 300,000 years later, formation of complex atoms, molecules. Slowly, around close to around a billion years and so later, you had the formation of the basic galaxies. And that is the span played by the entire theory, or what the theory tells us. Simply put, the Big Bang theory tells us that the universe as we know it started as an infinitely small, hot, and dense single point that inflated and stretched. First at unimaginable speed, much faster than the speed of light, and then at a more measurable rate over the next 13.7 billion years to the still expanding cosmos, or the celeste that we know even today. Okay, that is about the origin of universe. Now, once the universe came into existence, you had the various galaxies. All the galaxies had various different stars. Now you had one of the star across the Milky Way galaxy, that is the sun. Around sun, planets developed, and these planets, they move around the sun. But why do they move around the sun? Why isn't it that all the planets, they move around the earth? Tomorrow, if let's say any of you basically feel aggrieved that I am such a nice individual, my country is such a nice country, why is it that the rest of the planets don't revolve around the earth? So what do you think? Why is it that the planets only rotate around the sun or move around the sun? Beautiful, Yuvraj. High gravitational force. Okay, gravitational force of sun is higher. Why? Because mass is higher. Okay, because sun is the largest object, the most massive object that we have, and that is why it extends a kind of a gravitational pull of attraction. That is why every object or every celestial object around in the solar system, they keep on moving around the sun. Now, that gravitational force you have to understand a bit. So, basically, when we talk about that gravitational force, so in order to understand that, will also help you understand, for example, how is it that the spacecrafts operate. We have had the recent launching of Chandrayaan 3. PSLV is going to be launched in a couple of days. So how is it that they operate? You'll be able to appreciate that. So first of all, understand the basic factor. Let's suppose you have a ball in hand. Let's suppose. Now, suppose I have this pen which represents the ball. Now, if I drop this pen, aided by the gravitation, it will simply fall down, isn't it? But then, so if I drop this ball, it will fall down here, aided by the force of gravitation. But then let's suppose this pen has a velocity. I throw this with a kind of a speed. Will it fall down immediately here? No, it will fall down somewhere ahead. Similarly, if I provide some velocity to this ball will have a kind of a projectile. It will fall somewhere here, isn't it? Again, aided by gravity, but just because it has got a kind of a speed, it will fall somewhere there, isn't it? So, here, when we talk about the sun, let's suppose, and let's suppose we talk about the various different planets, any planet. Now, ideally, this planet would want to fall upon the sun because of the force of the gravitation. This is the area, or this is the direction in which the force is acting. But since the time of its formation itself, the planet has got certain amount of speed. So, where will it fall? It will fall somewhere here. Here again, there will be a force of gravitation acting towards the center. But again here, as it has come to this point, it has gained some speed. So, because when any object falls, it gains some speed, doesn't it? So, here again, it will end up, rather than falling straight, it will end up somewhere here. Again, here it has got speed. Again, it will fall somewhere here. Again, it has got speed. So, at every point of time, it is the force of gravitation towards the sun that is basically trying to pull the object, pull the planet. But in that process, because it has got speed, it keeps on revolving around the sun. That is the law, or due to the law of gravitation, or due to the force of gravitation. The same force is at play when moon revolves around the planet Earth. The same force is at play. The same force is at play when you launch any particular satellite. And this is something that you would be able to associate with, because I'm sure most of you would have followed the current affairs portion. So, when we talk about, let's suppose, any particular, let's suppose, any satellite launch. Recently, you had the Chandrayaan launch. Now, here you see the rocket moving up. Now, what is the purpose of having that rocket, that large fuel? It is in order to provide them speed. A speed close to around 11.2 kilometer per second. That much speed, 11.2 kilometer to 11.5 kilometer per second, which is also referred to as escape velocity in the portion of physics if you will study. So, with that, the rocket is able to provide that kind of a speed. And with that speed, the object simply escapes the gravitational pull of attraction immediately. And then you will see that the rocket falls off, the satellite is kept. And this satellite then automatically, it is pulled by the gravitational force of the planet Earth. but that rocket has provided it with a speed. So that satellite will keep on, just like in this scenario earlier, this satellite will keep on moving around the Earth. So that is the entire principle driving the movement of objects around each other in space that you come across. Okay, now, uh, who speed up the planet to move around and why it not go closer to the sun? Chandrasekhar, right at the time of its formation, the various different planets they have been created earlier. Also, you had dust particles which basically were attracted to the sun, and in their portion of getting attracted, they would have a kind of a circular motion. So it is a kind of a gravitational wave which is created. The space time that is warped. So imagine if you have a bed sheet. Imagine that now, if let's say you have a bed sheet and four ends of it are held across very tightly, you keep a large spherical ball in between, what will happen? It will create an incline. Now, that is the space time disturbed by the sun. Now, if you put anything close to that particular bed sheet, automatically it will keep on getting attracted and will start coming closer to the central point. That is the similar thing observed in the universe as well. But then, why is it that the objects don't immediately fall across onto the sun? It is because the outer space is a vacuum, it is space. It doesn't have any gas. So there is no loss of momentum which is happening. Ideally, if they would have lost momentum after every movement, they would have fallen to the sun. But because it is space, it is vacuum, they are able to maintain their movement. Okay? Sakshi, I hope it answers your question as well. Why the speed is not decreasing? The speed is not decreasing because the gravitational force is still there and there is no such resistance offered in the path of movement of these planets. That is why they are able to maintain that. These orbits that you see, these are imaginary, Gaurav. Yes. Okay. Why Earth is not as big as Jupiter? So various different planets have been created as a process of collisions that have happened, but you have to understand that each of the planets they have different shape and sizes, isn't it? So for example, few more collisions would have happened in the creation of Jupiter, much many more collisions would have happened. So same is the case with humans, us humans. Even in a family, people look different. Don't we say that why is it that person is taller or that person is smaller? It depends on the formation itself. Uh, if something struck the planet changing the path, will it spiral into sun? It might, or it might also give a further momentum to change the orbit or increase the orbit of the planet. Okay. Why meteorites fall then? Because they are very, very small in comparison and they also keep on revolving. But any of the time that they encounter any atmospheric resistance, that is where they lose the momentum and then they are attracted by that particular planet. Okay. Now, then we come to the planet Earth and intricacies thereby, or the details thereby. So, when we talk about planet Earth, it rotates around its axis. It keeps on rotating around its axis. Now, the portion which faces the sun experiences day, and the portion which is away from the sun experiences night. So, this is something which is differentiated by an imaginary line, and that imaginary line is referred to as circle of illumination. Okay. So the portion facing the sun will experience daytime, the portion away from the sun will experience nighttime. And continuously, the planet keeps on rotating from west to east. Okay. and this differentiates day and night. Now, for one complete rotation, it takes the planet close to around 1 day or 24 hours. That is required in order to achieve one complete rotation. But then, when we talk about the rotation here, okay, so when we talk about the rotation here, you have to understand that the planet in itself is rotating, but then different places they will experience different speeds of rotation. I hope we have seen a globe earlier or any spherical object we have rotated earlier. So, when we talk about the rotation, the speed at which, let's say, the central point rotates, that is not the same speed as which the top point rotates. So, that is the speed of rotation. You will get the requirement or the importance of it when we come over to the portion of climatology. And if you want to understand it with the help of, let's say, an animation, so on YouTube, I don't know how many of us are aware of it. On YouTube, we have started an initiative of helping you understand geography with the help of a better visual means. That will be or that is something which is available on the tablet as well, those of you who have tablet. So there you will get the animations of these particular portions as well, about rotation, about latitude, longitude, the orbit of the Earth. So you can check out our YouTube channel, that is Byju's IAS YouTube channel. You can check out, and I don't know how many of you have seen that, but there you will get a crisp animation if you require that. Okay, uh, I have seen. Okay, good. And Vivek, the link, just go to the Byju's IS videos that have been uploaded. You will find that. It is not very difficult to find. I'm sure you will not be confusing CNA videos with the videos of geography if animations are there. So I hope that is. In the tablet, it is there in the portion of basics, Rennie, in the portion of geomorphology and earlier portion of it. So there also you'll be able to look at that. Okay, only if you want to understand through animation, not it is not something which I'm forcing upon you. But understand the logic here. A sphere is rotating. Okay, consider a sphere for a moment. A sphere is rotating. And understand what I'm trying to convey here. I'm trying to convey here is that as this point, as the entire sphere is rotating, I stand to argue in front of you that the speed of rotation experienced at the region of equator or at the central portion, this is going to be much faster as compared to speed of rotation observed around the poles. Why is that? Let us try to have our own proof. So when we talk about speed, I'm sure all of us are aware about the formula of speed. Speed is equal to distance by time, that is distance covered by time taken, isn't it? That is the speed, formula of speed. Now, let me have your attention for a brief moment here and let us understand what do we mean by this. So suppose here I have this particular region. I also consider this particular region, right? And let me also consider this particular here. We have drawn three circles across the planet. This one that I'm drawing right now is representing the central point of the planet. So let's name this circle 1. Let's name this circle 2. And let's name this circle 3. Now I'm sure all of us would have studied about what is the length of the circle. How do we represent the length of the circle? By 2 pi r, isn't it? Very simple, length of the circle. So simply, rather than going into the formula, can I not say that length of circle 1 is greater than length of circle 2 is greater than length of circle 3? I can say that. We can figure it out just by visual appearance, that circle 1 is going to be the lengthiest, circle 2 slightly smaller, circle 3 very significantly smaller. We can say that. Now, in this case, here, in one rotation, let's say an individual is standing here or anywhere. In one rotation, you reach back to your original position, regardless of whichever point you are. In one rotation, you will reach back to your original position. So, distance covered by time taken will give you the speed of rotation. So, let's suppose an individual is standing here. That individual is A, who is standing at equator. Then you have an individual B at circle 2 and individual C. So, in one rotation, let's assume one rotation takes 1 day. For ease of calculation, let's assume one rotation is 1 day. So, in one rotation, distance covered by A distance covered by A will be how much? Length of circle 1, isn't it? Distance covered by B will be length of circle 2. So, we have seen that length of circle 1 is greater than circle 2 is greater than circle 3. Can I not say distance covered by A will be greater than distance covered by B will be greater than distance covered by C? Because C is covering the smallest circle, that is circle 3. Now, what is speed? Speed is equal to distance by time. Time in every place we have taken as 1 day for one rotation. That C will also cover that much distance in 1 day. A will also cover that much distance in 1 day. B will also cover that much distance in 1 day. So, can I not say that speed of A is going to be greater as compared to speed at B is going to be greater than speed at C? I can say that, isn't it? That, why do I say so? Because at the central point, that is where any sphere is going to be the widest. Any sphere that you have come across in your day-to-day life, where is it widest? At the central point. So at the central point, this sphere is going to be the widest. And that is the largest distance to be covered in 1 day. So a person standing at the central point, or the equator as it is known as, that person will cover the largest distance in 1 day, isn't it? So that is where the speed of rotation is fastest at the equator and reduces to zero at the region of the poles. Why zero at the region of the poles? Anyways, the circle size keeps on reducing, the distance traveled keeps on reducing. When you come exactly at the pole, as the sphere is rotating, the person at the pole is not moving at all. If, let's say, this planet is rotating continuously, an individual standing here, that person is not moving anywhere. So that is why speed of rotation at any point at equator is close to around 1600 kilometer per hour. And as you move towards the poles, the speed begins to reduce. So hence, it decreases to zero. So speed is fastest at equator. This is the reason why various different spacecraft launches, satellite launches, rocket launches that you come across, they are carried out closest to the equator as much as possible. Even in the case of, let's suppose, take the case of United States, it is their launch pads, they are built in Texas or in Florida, the southern states of United States. That is as close to equator as they can get. Take the case of India. We don't have satellite launches in the northern part. Why? We have it at Sriharikota, right? Significantly to the southern part of India. There's another one being developed further south. So closer to the equator because the speed is already high. And as the speed of rotation is already significantly high, any further speed that the rocket will provide, that will be able to put the satellite in orbit safely. This is also the reason why, if you take the case of the French Space Agency, the larger satellites that they launch, more than 4 ton of satellites that they launch it from South America, from French Guyana. Why? Because it is easier to provide small amount of additional speed at the region around equator. Okay, so that is basically about the portion of the speed of rotation and rotation of planet. Okay, can did some such questions can come like speed of earth on different latitudes? No, that calculation won't be asked, but that basic understanding will be checked, will be tested, whether you are aware of that the speed of rotation is different at different latitude. Okay, Divyanshi, I can't understand the speed point. How will have more speed? So the same sphere, take do one thing. Today, what you can do is any spherical object that you have in your house, take a tennis ball, a rubber ball, anything that you have, even a larger watermelon or anything can do. Try to rotate it around a point. You will observe that the central point covers a larger distance. So, in one rotation, if someone covers a larger distance, obviously that speed will be more because speed is what? Now, few of you might have this particular doubt in your mind that planet is one, we have one solid object, then why he's saying that equator has a different speed, other places are with different speed, are they moving separately but we have one planet? I hope that is not the doubt, because if that is the doubt, understand that even though you have one entirety of a planet, all of the places will never be moving at the same speed. Even if the planet rotates as one, all the places will never be rotating at the same speed. Take a globe, for example, any globe that you have in your house. Observe that the hinges around the poles, there is not much movement, but at the region of the equator, there is a complete movement. So that is why, because the distance to be covered in a spherical object is different in one rotation, hence different places indicate different speed. Okay, I hope that is understood. How A is having more speed than area? Okay, and this question is not clear. Mary, you will be able to look at it from the NCRT website itself. Nazarkar, yes, correct, absolutely clear. And can we study maps from the globe? Absolutely, yes. And okay, the question still persists that why A is having more speed as compared to the others. Forget about speed for a moment and the planet Earth. Think about what is or what is the formula for speed? Isn't it distance by time? When you think about speed, isn't speed equal to distance by time? So If an individual A covers larger distance in the same time as compared to B, can't we say that A will have larger speed as compared to B? We can say that. So, when we talk about an entire sphere rotating, imagine here if this is an entire sphere, let's suppose an individual is placed here as C, an individual is placed here at A. Here, do you think that in one rotation, the distance covered by A will it be similar to the distance covered by C? Ever? No. Distance covered by A will always be greater because in one rotation, A covers a larger part of the planet, larger radius is covered, isn't it, in one rotation? And in that rotation, how much distance has C covered? This smaller distance. So, how can we say if the distance covered is different in the same time period? Can we ever say that the speed of rotation will be same? Never. Okay. I hope that is understood. Now, satellite launches near equator because, see, understand that Bansika, when we have the fastest or the fastest speed of movement is at equator around 1600 kilometer per hour. So if, let's say, a rocket is launched at a place which is already moving at 1600 kilometer per hour, so that rocket will have more velocity as compared to being launched from a place which has, let's say, a speed of rotation of 800 kilometer per hour. So that rocket already will have more velocity. Imagine that you are in a bus, sitting in a bus which is stable, and that bus, or basically take a better example than this. Let's say you have a ball in your hand, right? And then you stand at a place and you throw the ball. The ball will have some velocity. But let's say you are running and then throwing the ball. So your velocity gets added to the ball's velocity. So then the ball will move with a faster speed. Now, in the case of the satellite launches, the aim is what? The aim is to provide maximum speed. So, better to launch the satellite from those spaces or those areas where there is naturally more speed, isn't it? Okay. Now, then after this, Saima, as galaxies move away, there may be a chance in future that they are very far from each other. Absolutely, yes. Okay. Yes. Break. Um, how much break will be there? 10 minutes would be sufficient, I guess. So we take 10 minutes. So Rishabh, in that case, understand even Russia launches its satellite from Kazakhstan. It doesn't launch it from Russia itself. So there you need to provide more boost. You need to strap on additional engines. Yes, Baikonur. Good, Afsha. So we take a break. We take a break of 10 minutes and then we come back. Okay. Abhishek, just remind me after the break. We'll take it up. So let's take a break for 10 minutes and we'll be back then. Vivek, because we don't have the developed facilities there in Andaman Nicobar. Somalia, it has changed significantly. The atmosphere has changed quite tremendously since the time of formation. Sakshi, no. The distance between the sun and the planet is not increasing, no. A confirmation about the audio, please. If the audio is clear and available. Thank you. Are there, if the speed is zero in poles, will the duration of day and night be affected? Yes, like I have heard that in some places the sun doesn't set. Is it because of the speed? No, that is not because of the speed. That is because of the tilt that the planet has on its axis. Okay. So, Soumya, how did we measure the time with so much accuracy? What was the procedure? Light, the measurement of speed of light has got various different experimental connotations, which have been if that is the thing that you are talking about it. So, which time are you talking about? So, if it is about the movement of light, that is something that we have the experimental basis for confirmation, and we know that it takes almost 8 minutes for sunlight to reach the planet Earth. Moon has no same gravitational power compared to Earth. Then how launched rocket enter the orbit of Moon and round about? Is there any difference between the? No. Moon's gravitational power is less as compared to Earth, Chandrasekhar, but does not mean Moon will not have a gravitational power. Any object with any kind of mass will have its own gravitational pull of attraction. uh, Sir Isaac Newton, very famously, he remarked that with the law that I have given, that is his laws of gravitation, the law that I have given empowers my finger to attract the star. So what he wanted to convey was that even that finger had a mass, it will have a gravitational pull of attraction towards the star. It is just that the mass is so less that the gravitational pull of attraction will also be negligible, but it won't be zero. Okay. Is universe still expanding? Yes. If that is the case, then why the planets are not expanding? It is not, universe is expanding does not mean that the objects are expanding. The distance between the objects are expanding. Imagine if, let's say, you have a balloon, and inside that balloon you have filled various different types of, let's say, paper pieces, confetti, etc. As you inflate the balloon, the objects will move away from each other. Does not mean the object themselves will start expanding. I hope you understand the difference. Okay. And does every object in the universe has its own angular momentum? Yes, Javeria, that is correct. And I hope that is understood. But Earth rotates straight in a similar position, or it tilts differently at a different time. It is tilted, but that tilt is never fixed. That tilt comes sometimes increases, sometimes. Do one thing. Take a tennis ball that you have at your house, maybe your neighbor's house, maybe your sibling's house. Keep it on a table, try rotating it. Observe if the tennis ball keeps on rotating continuously at the same angle, or does the angle change? It will change. Depending upon the center of mass and gravity, that tilt will always be maintained. Okay. And just to give you a kind of a broader idea of how the motion actually takes place is, please understand that even the sun that we are talking about, even this sun is not static, by the way. Just in order to expand your mental horizon and for you to be thinking slightly at a greater level, even this sun is not static. This sun keeps on moving continuously across the Milky Way. It takes multiple years to do so, but it does move, and its speed is very high. So imagine, as the sun is moving, the planets keep on getting attracted and rotating around that moving sun. And that is the kind of, at any point of time, the elliptical orbit that you see, it is that elliptical orbit which is represented. Okay. So it is basically aided by that gravitational pull of attraction, and that is what controls everything. Okay. Now, here, when we talk about the revolution of the planet, so the earth is continuously revolving around its axis. Now many of you have this question which you are repeating continuously, that why does the planet have a tilt? Why doesn't the planet rotate in a straight manner? Why will it have a tilt at all? Why is it that it has an angle of inclination at all? So that is why I had told you to take that experiment of a tennis ball. But nonetheless, understand it in this way, that when we talk about planet Earth, it is not a perfect sphere, it is an oblate spheroid. Okay, so if you think about it, it is not a perfect sphere, means what? It is not uniform, it is bulged around the equator. So this planet is bulged slightly around the equator, and that bulging provides provides for a different placement of center of mass. That is why, as this object which is bulged, as it starts to move or rotate, it tends to tilt, and that is why it has got that tilt. But is that tilt always consistent? The answer is no. But it is constant for a fairly long intervals of time. That tilt varies ever so slightly every 14,000 to 20,000 years. Every 14,000 to 20,000 years, that tilt tends to increase ever so slightly, again decreases ever so slightly, again increases ever so slightly, again decreases ever so slightly. But that tilt is maintained. Why? Because of the shape that the planet has. Now, with the same tilt, the planet keeps on moving around the sun in an elliptical orbit. And it is because of that tilt that different areas get a varying amount of sunlight. You would have experienced that during the summer time or the summer season. The days are particularly long, the nights are particularly short. Let the winter season come in, and you will find that days are short and the night time is longer. Why do you think this happens? When the days are short, means what? That your portion of the planet is getting exposed to sunlight for a small duration. It is away from sunlight for a longer duration. When the days are long, means what? Your portion of the planet is experiencing sunlight for a much larger duration. So, it is that tilt of the planet on its axis which creates different areas of illumination, or the circle of illumination is different. How? Let us try to understand. So basically, when we talk about Earth's movement around the sun, so the average distance is around 93 million miles, close to around 147 to 150 million kilometers is the average speed between the Earth and the sun. It is not consistent because it is a sphere, it is a kind of an elliptical orbit. That means at one point of time in the year, the Earth gets closer to the sun, and furthermore, it will get farther away from the sun. But before that, let us understand the aspect of Earth's movement along the sun and the various these dates. So, first of all, if you observe this particular image, you will observe that planet Earth moves around the sun in an elliptical orbit. So there is a distance, there is a point, there's a location, there's a time of the year when the distance between the Earth and the sun is the maximum. And that distance turns out to be roughly around 152 million kilometers. And again, obviously, it is an elliptical orbit, it is not a spherical or a circular orbit. So, because it is an elliptical orbit, there will also be a time when the Earth is closest to the sun, and that is roughly around 147 million kilometers. So, the point or the location of the planet around the sun, when the planet is farthest away from the sun, when the distance is maximum, that is known as aphelion. Why the term aphelion? Helion here is derived from the term helios, means sun. So this location, when it is farthest away from the sun, so that reference, ap refers to being far. So aphelion, farthest away from the sun. And when it is closest from the sun, perihelion, with reference to the sun, it is closest. So this location is referred to as perihelion when the earth is closest to the sun, and when the earth is farthest away from the sun in its orbit, it is aphelion. Similarly, when we have the moon rotating around the earth as well, there also moon will come closest to the earth slightly and then will again move farthest away. But here, when we are measuring the distance between the earth and the moon, sun is not a reference point at all. So when you are measuring the distance between the earth and the moon, you have the earth as the reference point. So you have perigee when the moon is closest, and same ap or aphelion here. Here you have apogee, because g, that is earth, is the reference point. So aphelion and perihelion, they will be points in the orbit of planet earth, because helion, sun, is the reference point. Apogee and perigee will be the points in the orbit of moon around the earth. Similarly, I don't know if you would have noticed, even during the launch of Chandrayaan 3 mission, if you would have noticed the screen that ISRO was broadcasting, there was a place indicating apogee, perigee. So even for the satellites which orbit the planet, there will be a point farthest away, apogee, with reference to Earth, and the ones which will be the closest, perigee. Okay, so that is how it continues to move. So basically, when we talk about it, so Earth at its maximum distance from the sun is known as aphelion, and the Earth at its maximum or its minimum distance from the sun, that is known as perihelion. Why? Because the orbit is elliptical. So obviously there will be a distance which will be farthest away, there will be a distance which will be closest. Okay, and then the point in the moon's orbit where it is farthest from the earth is known as apogee, while it is closest approach is referred to as perigee. Okay, I hope that is understood. Okay, now here, why the orbit is elliptical, why the orbit is not spherical? Because in general, outside in the nature, when you talk about, see, even that orbit keeps on changing ever so slightly. It is not as if God has given this orbit and the planet will continue to move in that orbit itself. Why in general you will find the orbits to be elliptical is because, as I was telling you, and I don't want to venture into the territory of science and physics significantly, when you have an object of mass, that is, let's say, a large object like the sun, now, there, that sun already warps the space time, the continuum that you have. It already provides a kind of a depression. So, the objects, they are being attracted. So, anything which is getting attracted will gain a kind of a velocity. Then it will do a roundabout, and then again, like a slingshot. So, that is how here it will gain velocity, and then it will again come back. So, that is how everything from the comets to the various planets to the various satellites, all of them you'll find have an elliptical orbit itself. Because understand, why do the orbits get created? Because of velocity. Now you need to have an absolute ideal velocity, some artificial velocity to be provided for a perfect circle to be crafted. It cannot be possible, because an object which is, let's say this is the sun, an object is trying to fall upon the sun, but it has got speed, so it will fall somewhere here at a farther distance. So you cannot have the condition that it should fall absolutely across the radius and have a circular orbit. That is why out there in the nature you do not observe a perfectly circular orbit. You will always observe a elliptical orbit to be at play. Okay, slingshot method is used by Indian satellites. Yes, that is correct. Yes, Mayank, correct. Now we come across the seasons experienced on planet Earth. Now, the seasons in general, they are basically driven by the exposure to the sunlight. Okay, so let me write it down in a kind of a point wise manner so that it is easy for you guys also to frame it in your mind. So, are dependent upon the exposure to light. For example, what do I mean by this? During the summer season, all of us know that the period in which there is sunlight is more, the daytime is longer, the nighttime is smaller. And during the daytime, you gain heat, during the nighttime, you lose heat. So that is why when the days are longer, you will have greater amount of warming, lesser amount of cooling. So during summer, greater amount of warming. During winter, daytime is smaller, nighttime is longer. So the period in which you are gaining heat, that period is smaller. The period in which you are losing heat, that period is longer. So that is why winter is colder, because you lose heat continuously. But why is it that this duration of daytime and nighttime will vary? Why should that be the case? The answer is the tilt of the axis. So, duration of exposure to sunlight varies. And when the duration of exposure to sunlight varies, that means, and why is that? Because combination of axial tilt and position of Earth along the orbit. Okay, let me tell you what do I mean by this. So, for example, in this particular image, you observe a position of the planet. Let's draw the equator here, a rough equator. This is what represents the circle of illumination, isn't it? Circle of illumination. Now, the portion in the northern part of the planet, that is the northern hemisphere, and this will be the southern hemisphere. Now, in this position, after observing the image carefully, let me rub down or erase down the portion of circle of illumination so that you are able to distinguish between daytime and nighttime on your own. So, out of the northern and the southern hemisphere, which one do you think has got a larger exposure to sunlight in this case? What do you think? Which has got larger exposure to sunlight? Clear? Northern hemisphere. So, northern hemisphere in this case, if I will consider only the northern hemisphere, observe that a significant majority of northern hemisphere is exposed to sunlight, whereas a small portion of northern hemisphere here that is hidden from sunlight. So, for a larger duration, northern hemisphere will experience daytime. So, can we not say during this time, northern hemisphere will have larger exposure to the sun and thereby have summer? Whereas when you talk about the southern hemisphere, observe here, for a larger area, it is nighttime. Only for a small portion, it is exposed to the sun. So there, it will be winter. Okay, this is axial tilt. Now, after this, we bring the planet in another position. Let's suppose we bring the planet here. Now the actual tilt is going to be the same. Actual tilt is going to be the same. Again, let us draw the equator. Now in this position, where do you think there is a greater exposure to the sun? Southern hemisphere in this case, isn't it? Correct? Southern hemisphere in this case. Why? If let's say I were to draw the circle of illumination here, how would the circle of illumination look like? Somewhere like this. Let's suppose I mark it as circle of illumination. Circle of illumination, again to repeat, is what? The imaginary line which separates daytime and nighttime, that is circle of illumination. Now here, can I not say that southern hemisphere is in a way tilted towards the sun and northern hemisphere appears to be tilted away from the sun in this case? Whereas in the previous situation, northern hemisphere appeared to be tilted towards the sun. So this will bring summers in southern hemisphere and winters in northern hemisphere. That means shorter days, longer nights. Now, that is the tilt of the planet. Now, think about a particular position. I will give you the write up of all of these, don't worry. Now, think about another position. Think about the position here. Now, the tilt that you had, the tilt is going to remain consistent. But here, if I have to ask you that which is the case of whether it is tilted towards the sun or away from the sun in this case, what do you think? Is the northern hemisphere tilted towards the sun or is it away from the sun? What do you think is the case? Pula, I don't feel it is a live session. So what do you feel is, if it is not a live session, what kind of session is it? Neither. Equinox, same day, kind of similar. Okay, good. So here tilt is still there, but it is neither tilted towards the sun nor away from the sun. It is tilted in a different plane altogether. So imagine if this is the sun, the planet would rotate like this. So if it is here, northern hemisphere is tilted towards the sun. If it is here, northern hemisphere is away from the sun. But if it is here, there is the tilt, but neither it is tilted towards the sun nor away from the sun. So both the hemispheres get equal exposure to sunlight. So in this case, both the hemispheres are or have equal exposure to sun. So in this case, the length of the day and the length of the night will be equal because you have equal exposure to the sun. Same will be the situation here also. In this case also, equal exposure to sun. So that is why between the summer and the winter comes the month of autumn. In India, when do we experience autumn? In the month of September, we experience autumn. And when is it that our day length of day and night is equal? On which date of September do we have the length of night and day to be equal? 23rd of September. Somewhere in the region between 21st to 23rd of September, that is when it happens. When exactly it is situated at this location where the length of day and night will be equal. And then we go to the extremity of winter, where we have very small days, long nights, very cold conditions. But again, before the summer comes the spring, and the spring is experienced in March. And which date of March is again where we will experience spring. In a date of March, we experience equal length of day and night. And what is that? 21st of March. So these are your equinoxes. Equinox means equal length of day and night. So let me just decipher this down, and we will finalize this, concise this in a kind of a note fashion so that it is easier for you to revise as well. So here we talk about, first of all, the winter months. Winter here, northern winter. So when I talk about winter, this is the location, or this is the position briefly. So this is your actual tilt, okay? And here, observe the Arctic circle. This is your Arctic circle. This is your circle of illumination, differentiating the day and the night, and this is your equator. Okay. Now, here, this is your northern hemisphere. This is your southern hemisphere. So, winter months in India, or this kind of a phenomena where the day starts becoming shorter and the night starts becoming longer, is experienced all the way from October, later part of October, November, December, January, and then to some extent even in February. From December onwards, you would observe that the length of the day starts increasing. Till December, the length of the day keeps on shortening, 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 and then again it will keep on increasing. This is the winter. Now, during this time, what do we experience? We experience shorter days and longer nights. Where? In the northern hemisphere. And longer days and shorter nights. Where? In the southern hemisphere. Why? Because the southern hemisphere, look, if this is the position of the sun, the southern hemisphere appears to be tilted towards the sun. Hence, greater exposure to the sun, hence, longer days and shorter nights. Now, if I ask you about the condition of length of the day, length of the night in the region of Antarctica or around the South Pole, what do you think will be the situation in Antarctica? Now, when you talk about Antarctica, regardless of how many rotations that does the planet carry out, this will always be on the brighter side of the circle of illumination, on the lighted portion of circle of illumination, isn't it? So, that is why during these months, Antarctica will have daytime, consistent daytime. Why? Because it will have a tilt perpetually towards the sun owing to the tilt of the planet. So the sun rays, they will not be very direct here. They will be slanting. Something that you would observe, let's say at 9 a.m. in the morning or 5 p.m., 6 p.m. in the evening. What is the location of the sun in the sky? Very close to the horizon, isn't it? So that is what you will observe in Antarctica. So in Antarctica, you will have constant day because it is consistently on the lighted portion of the circle of illumination. Circle of illumination is what? That imaginary circle differentiating the area exposed to the sun and area hidden from the sun. So this is your day and this is your night. Now, if I were to ask you that what will be the condition in the Arctic region or the Arctic circle in terms of length of day and night, what do you think? Will the Arctic region have longer nights, shorter days, or something in that category? Very good. It will have consistent night time because observe the region of the Arctic. It is on the darker portion of the circle of illumination. That is why during these months, the region of the Arctic and the land very close to the Arctic, they experience continued nighttime. So, in the region of the Arctic, continued night. No daytime. Now, this condition of the location of the planet across the sun or around the orbit, this will have a kind of a tendency where, let's say, from September itself, this is September, let's assume this is March, this is December. So, from September itself, the length of the day will start shortening, the length of the night will keep on increasing. Because as the planet comes here, as the planet comes here, the level of exposure with the tilt keeps on differentiating. It is on 21st of December when there will be that absolute tilt experiencing the sunlight. So it is on 21st of December when you experience what is referred to as the winter solstice or the December solstice, whereby the length of the day in the northern hemisphere is the shortest, length of the night in the northern hemisphere is the longest. And simultaneously in the southern hemisphere, length of the day is the longest, length of the night is the shortest. So let me write it down. On 21st of December, you have the winter solstice as per northern hemisphere or the December solstice. Now, in this case, in the northern hemisphere, length of the day is the longest, or rather, is the shortest. Length of night is longest. Whereas, when we talk about the southern hemisphere, length of the day is longest, length of night is shortest. Okay, so very quickly, let me tell you a recap of what is experienced during the winter months, the winter months that we experience in northern hemisphere. We in India, we are in northern hemisphere. That is because we are above equator, to the north of equator, hence northern hemisphere. Now here you will observe that during the winter condition, it appears as if the northern hemisphere is tilted away from the sun. It is the southern hemisphere which appears to be tilted towards the sun. So, if you draw the circle of illumination, you will observe that a larger portion of the northern hemisphere at any point of time is hidden behind the sun, and a very small portion is actually exposed to the sun. That is why in the northern hemisphere during these months we experience shorter days because of smaller time in which for which we are in front of the sun, and longer nights, larger period behind the sun. Whereas in the southern hemisphere, the exact opposite happens because a larger portion is actually tilted towards the sun. They will have longer days and shorter nights. Now, in the region of Antarctica, if you consider this position, regardless of endless amount of rotations that you carry out in this position, Antarctica will always be on the brighter side. So, Antarctica during these months will experience continued daylight, whereas the region of the Arctic and the Arctic Circle will not experience sunshine at all. Why? Because the tilt ensures that the position of the Arctic in this condition never comes on the brighter side of the circle of illumination. However, when we talk about the movement of the planet around the orbit, so from September, that is when we have equinox that we had discussed, the length of the day and the night being equal. From September itself, the planet has its trajectory and it reaches the peak point, or in terms of the tilt and the absolute length of day and night, the peak is reached around 21st of December. That is referred to as the December solstice or the winter solstice. Now, during that point or at that time, in India also you would have observed in December, on 21st or 22nd of December, we have the shortest day and the longest night, because the northern hemisphere is tilted farthest away. Whereas in the southern hemisphere, you have the longest day and shortest night. So here, that is the case of winter solstice or December solstice. What about the situation when, let's say, we come in the month of March? In the month of March, and even in the case of September, when we talk about March or September, okay. Now, when we talk about March or September, this is a journey from one season to another. So, if you have to understand here and here, during these conditions, both the hemispheres, they will experience equal amount of solar rays. Both the hemispheres. So, if both the hemispheres experience equal amount of solar rays, so can we not say length of day equal to length of night? Length of day is equal to length of night. Now, this is a condition which is referred to as equinox. Okay, that is a condition that we refer to as equinox. So, equal length of day and night. It happens on 21st of March, 23rd of September. Okay, so here you will observe, even in this case, you have two types of equinoxes: autumnal equinox and vernal equinox. Okay, so the one which happens in the month of March, this is vernal equinox, and this is what is referred to as, because autumn, hence autumnal equinox. Okay, then what happens in the month of September? So in the month of September, or rather in the month of summer, when we talk about the month of summer, so here the exact reverse takes place as observed from the winter months. The exact opposite. This is your Arctic Circle. This is your equator. This is your circle of illumination. This is your axis. So Dilpreet, this happens only on one day, as you said, 21st March and 23rd September. Yes. So equinox will happen twice a year, isn't it? So 21st of March, when it is between winter and summer, that is the vernal, and then 23rd of September, around 22nd, 23rd of September, it is not fixated. So around 23rd, 22nd, 23rd of September, that is the autumnal equinox. Okay. In equinox, what happens in Antarctica and Arctic? In both these areas, you will get some amount of sunlight, because both have some exposure to the sun. Now, this is the month of summer. So, in the month of summer, where we generally talk about immediately after the month of March itself. So, from April, May, June, July, all the way till August. So northern hemisphere is tilted towards the sun. So in the case of northern hemisphere, longer days and shorter nights. In the case of the southern hemisphere, we have shorter days and longer nights. Okay, this is what is regarded when you have longer days means prolonged heating period, so hence summer. And when you have, in the case of the southern hemisphere, shorter days and longer nights means winter. Now in this situation, look at Antarctica, the region of the Antarctic Circle, if you observe. Now in this case, Antarctica will be under permanent night. Night. What about the region of the Arctic? If you observe the region of the Arctic and the North Pole, Arctic, constant day. Observe how this has changed from winter to summer. Here also, just like the case with the winter solstice, here also you have a condition of solstice which is reached on 20. When is it reached? In June. It is reached on 21st, 22nd of June. That is when you have the June solstice, or what is also referred to as the summer solstice. So that is on 20, sometimes 22nd, but mostly 21st, 22nd. So 21st June, that is what is considered to be the June solstice or summer solstice. In this case, northern hemisphere, longest day and shortest night. Whereas southern hemisphere, shortest day and longest night. Okay? Do the people face difficulty of both the poles to survive? Taran, people don't live in the polar region. Neither in the North Pole or the South Pole, people don't live there. Ghulam Mustafa did not get the Antarctica and the Arctic point. So, Ghulam, I want you to have some level of imagination into how the planet will rotate. Planet consistently rotates from west to east. Consistently. Now, this is the position. Now, if it rotates once more, Antarctica will still be here. Is it exposed to sunlight? Absolutely not. Arctic is still here. Will it experience darkness? Absolutely not. So that is why for the entire duration that the position is like this, where the northern hemisphere is tilted towards the sun, Arctic will be tilted towards the sun. When the Arctic is tilted towards the sun, why will it have night time at all? Regardless of the rotation, it will always be tilted towards the sun. Same is the case with Antarctica. So that is why you have almost 4 to 5 months of daytime in Arctic and 4 to 5 months of nighttime in both these areas. For example, right now, when we talk about the month of July, now in the month of July, you would be experiencing nighttime in Antarctica. But slowly in 2 to 3 months, Antarctica will experience daytime. And that is why majority of the polar expeditions that you find moving to Antarctica, they will explore Antarctica in the months of when you have daytime in Antarctica. That is in the months of November, December, January, February. That is when the polar expeditions they are carried out. Okay, I hope that is understood, Gulam. And does Australia receive rainfall, Mushtaba? Only certain parts and certain hill areas. Other than that, no. Aksha, why the half of Earth gets sunlight? How is it? Paint me a scenario where the entirety of Earth can get sunlight. I will be more than happy to accept if the entirety of the planet, any spherical object, if there is a source of light, only half of the sphere will be exposed to sunlight. How can the full sphere be exposed to sunlight? Okay. Javeria, in London, people are experiencing heat waves now. What is the reason? Okay. I had the same question from Gulam Mustafa as well. That why is it that Europe is experiencing heat waves? First of all, how many of us here right now have an idea about heat waves? First of all, be very clear with that. Now, those heat waves are being experienced because of a twin effect of jet streams, the variation in jet streams, as well as the Atlantic meridional overturning circulation. Now, we have not talked about any of these, neither the basic of any of these. So, please wait. When we come to those areas, we will be discussing those areas. Okay, just because a particular topic you find, this is one of the fallacies that most of the candidates they do commit, is particularly in a subject like geography, where what they will do is they will hear, okay, cyclone. If I if someone teaches them cyclone, they are not interested. But when it is reported in news that a cyclone is coming, they would want to know about the cyclone without knowing the basics. So what will happen? They will rectify, they will forget before the next cyclone, and obviously before the exam. So let us not jump from event to event. Let us talk about why anything happens. And the very reason I'm spending so much time in the basic of the seasons is eventually, be it the condition of jet stream movement, or the condition of, let's say, AMOC, or the condition of cyclone or heat waves, everything is basically instigated by the seasons. So I hope you understand the seasons first. We will come to climatology. Trust me, any of the questions that you have, we will address. Okay? Is that understood? Okay. And Dinesh, we have that on YouTube as well. You can look at it. Uh, Divyanshi, just try to understand each and every day class. See, there is no such success key. What if you are searching for a key to success, that give me the key to success and my geography will be beautiful? So that key to success everybody would have consumed in day one itself. As of now, all you can do is try to take one class at a time. Ensure that you understand everything taught in that class without jumping ahead, without jumping back. Trust me, in 24 modules you will be in a different place as compared to now. Okay? Yes, Yash, it can be used. Yes, Ilma, correct. Do people never live in polar regions? Absolutely not. In none of the poles people are living. Arctic is basically sea and ice above the sea, whereas Antarctica is a, polar landmass where the temperatures drop to minus 50, minus 80 degrees Celsius with a wind speed of almost 200 kilometer per hour. Okay, right? Now, prime meridian intersect which state of India? Rashida, prime meridian does not even come to India or does not even pass through India. Now, here, we introduce ourselves to the set of imaginary lines created across the planet for the reference of timekeeping and also for navigation purposes. And those are latitudes and longitudes. When we talk about latitudes, these are also referred to as lines of parallel. Lines of parallel. Because the latitudes, these are the horizontal lines that you see. Now, these were initially given to provide aid for navigation, for people moving from one region to another, to help them, to aid them that which area of the planet you have covered or what distance you have covered. That is where these imaginary lines were created. Now, these are imaginary lines running horizontally from left to right or right to left, anything that you consider. But wherever you consider up to be north, etc., It is left to right that you consider these latitudes. Now, these do not meet with each other. Now, we will talk about the various important latitudes. We'll talk about how to measure the angle of latitude, etc. But you also have the imaginary lines which are used for timekeeping purposes. For example, when we talk about, let's say, the sun. Karthik, what is your question? Please let us know. Suppose you have the sun. Now the planet is rotating from a direction of west to east. Obviously, this place will experience sunlight much earlier as compared to, let's say, South America, isn't it? So here, let's suppose 8 a.m. If it is there 8 a.m., here it will be a different time altogether. So you need a kind of a reference pointer for keeping time. And for those purposes, you have the longitudes which are drawn. Now, these longitudes, they meet each other at the north and the south pole. These are also imaginary circles which will intersect each other at the north and the south poles. Now, the longitude passing through Greenwich Royal Observatory in Greenwich near London, that has been chosen as the prime meridian or the longitude for reference. Here you have the largest circle at the center, that is chosen as the latitude of reference. Here you have the one passing through Greenwich in London, near London, that is chosen as a meridian or longitude for reference. These are named as 0 degree latitude and this is 0 degree longitude. Okay. Accordingly, the planet is divided into northern hemisphere to the north of equator, southern hemisphere to the south of equator, eastern hemisphere to the east of prime meridian, western hemisphere to the west of prime meridian. And we are in the eastern hemisphere, eastern and northern hemisphere. Okay. Now, here, when we talk about latitudes, how do we measure a latitude? Because you would have heard about 10 degree north, 20 degrees south, 30 degree north, 40 degrees south. How do we get that? So that is kept in mind or that is calculated considering the position of the equator, considering the location or the angle made by equator. Let me explain how. So for example, let's suppose we want to measure the angle of the latitude that you see drawn here at P. This is your equator at Q that you see. So I have to measure the latitude angle here. Now what do I do? First of all, I will draw an imaginary line from the equator joining the center of the planet. It will be an imaginary line, obviously. I will draw an imaginary line from here to the center of the planet. Then, the longitude that I want to measure, I will draw an imaginary line from there to the center of the planet. And I will join these two. I will join these two. Now, whatever angle this comes out to be, it is to the north of equator. Let's suppose this angle comes out to be 40 degrees. It is to the north of equator. So this will be named as 40 degree north. Suppose, let me take another example. Suppose I want to measure the angle of a longitude here, or rather latitude here. The latitude here. Now again I will follow the same principle. I will draw an imaginary line from equator to the center. I will draw an imaginary line joining this latitude that I have to measure to that center. I will measure the angle. Let's suppose this angle is 30 degree. It is to the south of equator. So this will be 30 degree south of equator. So that is how you give the measurement to the various different latitudes. You have certain important latitudes or latitudes of importance in general. Equator is the latitude, the largest latitude in general is equator. It will have the largest circle. Then you have Tropic of Cancer, 23 and a half degree north, Tropic of Capricorn, 23 and a half degrees south, Arctic Circle, 66 and a half degree north, and Antarctic Circle, 66 and a half degree south. So that is basically, so observe, none of these latitudes, they will ever meet. The latitudes don't meet, but the longitudes, they do meet. Where is it that the longitudes meet? They will meet at the polar region, North Pole and South Pole. That is where all the longitudes will meet. But when we talk about longitude, before that, the definition of the latitude, just for your reference, even though definitions are not asked in the examination. So, latitudes are imaginary circles parallel to the equator. On a map where north is up, latitudes run laterally left to right. They are named after the angle. Now, how are they named? They are named after the angle created by a line connecting the latitude and the center of the earth, and the line connecting the equator and the center of the earth. So what that means, line connecting that longitude to the center of the earth and line connecting the equator and the center of the earth, measure the angle, you get the angle of the latitude. Okay, right? Tropic of Cancer, Tropic of Capricorn. So, Cancer, Capricorn, these are your constellations of stars as well. So, it is named depending upon at which point of time, what is the visual or the kind of a visibility of which kind of a constellation. That is also based upon how it is named. Okay. Now, then we come to the longitudes. Now, longitudes basically, the need was felt to keep a reference time because someone in China might say that at 5 p.m. this will happen. Now, someone sitting, let's say, in Greece, if that person receives the news that at 5 p.m. this will happen, how is that person to figure out 5 p.m. of Chinese time or 5 p.m. of my time or 5 p.m. of British time? So that is why need was felt that as the world started getting smaller because of ease of conveyance, etc., and ease of movement, so there needs to be a reference time which needs to be kept. So for those purposes, at that point of time, obviously in the 1800s, London was almost the most powerful city of the entirety of the world because of the British rule and the British power. So UK or Britain was the center in terms of the geopolitical power setup. Now the postmaster of general was obviously a very prized status as a government employee. Now postmaster general of London, he decided that the longitude passing through the Royal Observatory, the apex observatory of astronomical understanding which was present. Now the longitude passing through the Royal Observatory should be made as a kind of a reference around which the entire world will adjust their time accordingly. So that is what formed the prime meridian. So that prime meridian is the one which passes through the Royal Observatory in Greenwich, close to London. Now, it is from that you have the universal time or the Greenwich Mean Time or GMT, Greenwich Mean Time, or what you hear as GMT. Okay, so it is with reference to GMT that you have the various different time zones which are kept. When we come to Indian geography, we'll also talk about the Indian standard time and the standard meridian passing through India. So in India, we observe the 82 and a half degree east meridian as the standard meridian. So Indian standard time is taken to be 5.5 hours ahead of GMT. So IST or Indian standard time, Indian standard time is 5.5 hours ahead of GMT, which means if let's say right now we have 8 p.m. or we observe 8 p.m. in India, so in Greenwich, what would be the time? Let me know. What would be the time in Greenwich if it is 8 p.m. in India? Beautiful. It will be 2:30 p.m. in Greenwich because Indian time is 5.5 hours ahead. Okay, so that it will be 2:30 p.m. in Greenwich. Now, this is taken as 0 degree. That is the prime meridian. Now, exactly opposite to prime meridian, what will be the angle? So, for that, let us take a top view of the planet Earth. Let us consider a top view of the planet Earth. Now, in this top view, let us do one thing. Let us crisscross this with the various different longitudes. Okay, let's assume all these longitudes, they are meeting at North Pole. We are looking at it above the North Pole region. Okay, now here, let's suppose this is the 0 degree. Let's assume this is the 0 degree or the prime meridian. Now, what will be the angle of this particular meridian that we have, the exact opposite of it? 180 degree, isn't it? Correct. Why 530 is fixed? Could it be 520 or 490? Uh, Jayant, that basically the time varies depending upon each of the meridians, each of the longitude, each of the meridians. So here this will be 180 degrees, isn't it? This will be 0 degree, the other one will be 180 degree. So this is your prime meridian. This is what is also referred to as anti-meridian, exactly opposite to it, anti-meridian. So in between them, the portion, this is referred to as the eastern hemisphere and this is referred to as the western hemisphere. Okay. So the equator also classifies the planet into two hemispheres. The prime meridian also divides the planet into two hemispheres. So longitudes are geographical positioning markers that run from the geographical North Pole to the geographical South Pole, intersecting the equator. They meet at both poles and specify the east to west position of any particular location. Prime meridian is set as 0 degree longitude and it divides the earth into the eastern and the western hemispheres. All the other longitudes are measured and named after the angle they make with respect to the center of the earth and the prime meridian. That means the measurement of the angle of any longitude is done in a very similar manner as we have done with the latitude. For example, let's suppose I want to measure the angle of this particular longitude which passes through P. I have got Q, which is my prime meridian. So again, just like in the case of latitude, here also, I will draw an imaginary line from Q to the center. I will draw an imaginary line from P to the center. These two will give me an angle. Let's suppose it is around 120 degree. Now, it is to the west of prime meridian. So this will be 120 degree west. Similarly, here you have 10 degree east, 20 degree east like that. It will go up till 180 degree. So this will be 10-degree east, this will be 10-degree west, this will be 20-degree west, and like that, it will continue to go on. Okay. Now, with each of the meridians, each of the longitude, that basically ends up exhibiting a time difference. For example, in India right now, you have 8 p.m., but then in Greenwich, we will be experiencing around 2:30 p.m. Obviously, why? Because it is to the west of India. So sunrise, sunset, all the things will happen a bit late. Why? Because the planet is rotating from west to east. So the east will always experience sunrise first. That is why Japan is referred to as the land of the rising sun, isn't it? Now, let us represent this on a kind of a flat map and let us try to understand here. So, for example, here you have the prime meridian indicated at Greenwich. Okay. Now, here you will find it is written ahead. Time is ahead. Here it is written before. What is the meaning? So, here, for example, when we consider the case of India, India is 5.5 hours ahead of GMT. Now, what do you observe here in this region? That is the eastern part of Russia, isn't it? Now, I want you to solve a bit of a complex mathematics here. Not a complex mathematics, a simple maths, but we as candidates of civil services have the ability to make things complex very easily. So, if it is 8 p.m., we have talked about this. So, if it is 8 p.m. in India, means it is 2:30 p.m. in as per GMT. Now here you see plus 12. Let's name this place as A. So what will be the time in A as of now? What do you think? All those who are writing 8 a.m., think about it again and read the question carefully. It will be 2:30 a.m. Correct. 2:30 a.m. of which day? Of 24th of July or 25th of July? It would be experiencing 2:30 a.m. of which date? 25th of July. Very good. Because this region would have experienced sunrise and sunset much earlier than India. So 2:30 a.m. at A, that is 25th of July. We are still experiencing 24th of July. Okay. Now, let me take you to another location. That is, as we move to the west of the prime meridian, the sunrise sunset will happen later. So observe here, that is in this region around Alaska, you have -11 here. -11. Right? Let's name this place as B. So if it is 2:30 p.m. GMT, 24th of July, what do you think will be the time in B, Alaska? What do you think? 1:30 a.m. Is that the case? Or 3:30 a.m.? Very good, Manikandan. Very good, most of you. It will be 3:30 a.m. at B. On which date? What will be the date there? 24th or 23rd? It will be 24th of July. Now, after this, take a brief moment, take a pause, okay? Bring yourself out of this complex equation and calculation that I have put you through. Now, Think about the planet Earth. Okay? In fact, in order to help you think that, let me have this depiction. Let's suppose if I were to represent this place A and this place B, wouldn't it be the case that A is here, B is here? I'm just representing it on a spherical map. Earlier it was on a flat map, I'm just bringing it on a sphere. So in the case of A, I'm experiencing 25th of July. Whereas in B, it is night time. So A and B both have night time, but one is experiencing the next day. So what demarcates the difference between the same day and the next day? Because the planet is a sphere, it keeps on rotating. How will we designate that when the next day will come? So that is why, for the ease of timekeeping, the exact opposite of prime meridian, that is around 180 degrees, that is the anti meridian, around that, an imaginary line is drawn. And that imaginary line is not a straight line, it is a zigzag line. And that imaginary line is referred to as the international date line. Okay, that is known as the international date line. It distinguishes one date from the other one. Why it is not a straight line? Why is it zigzag? Because why is it zigzag? So as to avoid the boundaries and borders of various countries, because in this region around the Pacific you have multiple small countries, multiple small different islands. So you don't want the date line to be passing through the middle of any particular island or a country. In that situation, one part of the country will experience the next day, the other part will be experiencing the previous day. So that is why, to maintain some amount of sanity, to have the kind of sovereignty and the respect to the sovereignty of the countries, that is why this international date line is zigzag. Now, why is it exactly around the region of anti-meridian? Is it the same as anti-meridian? So it is not the same as anti-meridian. It is at that particular place, however, because that is exactly opposite of GMT or the prime meridian. So because prime meridian is taken as the reference point, the opposite of it, that is a 12-hour difference from each side, that is something which will be considered as the time or rather the date line. Now, when you move from one side of the date line to the other side of the date line, you have to adjust your watches, you have to adjust your clocks. How? Let us understand it. Um, Kindly make us understand the time differences between two different places. Ideal has been drawn near to anti-meridian, yes. Where is anti-meridian? That the around the Bering Sea, around the region of Pacific Ocean. Pranchi, it means ideal is drawn at the same region where the anti-meridian is, but it is not the exact anti-meridian. Okay. Now, here, when we talk about the regions A and B here, let's suppose this is the date line, imaginary. Okay. Let us imagine this is your date line. So, this will be, I hope the directions are clear to all of us. We are mature enough to not bungle up the directions. This is your east, this is your west, this is your south. So as per the date line, this will be your east. As per the date line, not as per the prime meridian, this will be west. So this is where, let's suppose it is Japan. This is where, let's suppose it is US. Now we have seen that in the region of Japan, they have already welcomed 25th of July. And here you have 24th of July. Let's suppose one of you, any of you, let's suppose we take the case of, um, let's suppose Chandrasekhar. Now let's suppose Chandrasekhar has got his birthday on 24th of July. Okay, let's suppose. Now Chandrasekhar, what he decides is that here he catches a flight and then travels to Japan. Now, when Chandrasekhar caught the flight, the time which was indicated was, or the date indicated was 24th of July. But when the flight lands in Japan, that region is already experiencing 25th of July. So, in a way, Chandrasekhar has lost one day of his life because now the next day will be 26th of July in Japan. So, in a way, Chandrasekhar has lost one day in his life. So, can we not say when you move from east to west of the IDL, you lose a day? Can we say that? Isn't it? So, can we say here as one moves from east of IDL to west of IDL, one day is lost. We can say that. Now, in your watches, which shows the date, you will have to do some adjustment because you have reached a new place. What is the adjustment that you will have to do? When you sat on the flight, it was 24th of July. When you have landed in the place, there it is 25th of July. So you will have to add a day, isn't it? In your calculator, in your calendars, in your watches, you will have to add a day. So here, add a day. Okay, we will add one day in the watches, in the calculators. Now consider the opposite of it. So here, when we talk about, let's suppose someone moving from Japan to US. Now that individual, again, let's assume Chandrasekhar has decided to move to US from Japan. So he caught his flight, his birthday was on 24th of July. So when he sat on the flight, it was 25th of July in Japan, but when he landed, US was still celebrating 24th of July. So he gets to live his birthday again. So in a way, can we not say that in his life, he has gained one day? We can say so, that in his life, he has gained one day. So can we say that as we move from west of ideal to the east of ideal, we will gain a day? Earlier, we lost a day. So as one moves from west of ideal to the east of ideal, one day is gained. Now, one day is gained. So in the watches and calculator and calendars, what adjustment do you have to make? You have landed from a place, or you have basically come from a place of 25th of July to a region where still 24th of July is being celebrated. So in your watches, in your calendars, everywhere, you will have to subtract a day, isn't it? So here, subtract a day. Okay. So this is what happens when you move across the international date line. Okay. So here, first of all, the date line is not straight. Why? Because it avoids the political boundaries and the country borders. Why? So that it doesn't cut any particular country in half, so that the country experiences the same date at all times. And then when you cross the ideal from west to east, you will subtract a day. Why? Because you gain a day in your life. And if you cross the line from east to west, you add a day. Okay, so that is what you experience in the case of the IDL. Okay, this is your IDL, the rough international date line. This is your IDL in the Pacific. That is where you have the imaginary ideal. Okay. So then I have SOMO or SAUMO. Then how is it that 1st January is celebrated all over the world at the same time? It is not celebrated all over the. Who told you it is celebrated at the same time? If that would be one of the biggest eureka moments that I will provide to you in your life right now, and one of the biggest amazing moments of your life is about to come right now. That when you have 12 a.m. in India, only India celebrates New Year's at that point of time. Japan celebrates New Year's almost, or New Year's Eve, almost 4 hours ahead of you. Even Australia celebrates 3 to 4 hours ahead of us. Rest of the world celebrates after us. So it is not as if all of us we celebrate at the same time, and when the TVs they go berserk, that means it is New Year everywhere. No, that doesn't happen. Okay, right? Now, after this, the systems of the Earth that we will be covering across the entirety of our course duration. That is, first of all, understand that planet Earth has been divided into typically four systems. And nowadays, fifth system is also considered because of its unique role. That is lithosphere, the land that we stand on, the land that we live upon, that is referred to as lithosphere. So this particular lithosphere is something that we will cover under geomorphology. Then you have hydrosphere, that includes all the water which is present across the planet, oceans, seas, etc. That is hydrosphere, we'll study in oceanography. Then you have the portion of the atmosphere, the air around us. Then you have the biosphere, all the living beings on the planet, flora and fauna, that you will study separately in the portion of environment ecology. That is included in the portion of biosphere. And then you have the cryosphere. Cryosphere here includes the frozen areas, that is the polar regions, and that is also the high altitude mountainous areas. These are permanently frozen. And cryos basically refers to anything with a very low temperature of frozen. So that is why that is referred to as the cryosphere. Okay. Now, here after this, we come over to the basic geomorphology that I would introduce you with. Tehseen, zigzag, why ideal is a zigzag is, please understand. So today I want you guys, I think many of us have not ever looked at what Pacific Ocean is. Please understand why ideal is zigzag. If let's suppose you have a particular set of island nation having many small islands like this here, would it be apt to divide the nation by two with the ideal? Absolutely not. If let's suppose ideal would have been a straight line, let's suppose what all of you are saying is that ideal should be, let's suppose ideal is a straight line, let's suppose. So that means this portion of Russia would be experiencing a different date as compared to the other portions of Russia. Imagine one portion of India celebrating a different date, other portion of India celebrating a different date. Would that make much of a sense? Absolutely not. That is why you will find that ideal is zigzag to avoid the country borders, the political borders, right? We have written that here as well. It is not straight but zigzag to avoid political and country borders. Okay, I hope that is understood. Cryosphere is basically the areas across the planet which are permanently frozen, the high altitude areas. That is the region to the top of the Himalayas. For example, they are referred to as cryosphere. Now, here, this is your, yes, ideal is imaginary. So, here we have the basics of geomorphology that you will be introduced to in various different paths. So, first of all, what you see here is Mount Everest. Actually, it is a mountain here. So, when we say a mountain, mountains basically, they are your conical features having a distinct peak, a conical peak, a sharp peak. and they will have a great height. Mountains and hills are different in terms of their height and their features. Generally, the slope will be significant, very steep in the case of a mountain, a conical peak like top. So, a distinct peak, distinct peak, right? Conical shape. Height will be very much. Now, above a particular height, you will generally observe things to be present in frozen condition, in frozen state. So that is where you'll find that the ice, it starts to fall down the slope. And from the very high mountains, you will also observe that large chunks, each of them weighing, in many of the cases, many hundreds of tons altogether, they start very slowly moving down the slope of the mountain. And those are referred to as glaciers. These are what you have as glaciers. By the way, before we conclude the class, an announcement and a gentle reminder for all of you that feedback sheets have been rolled out for the classes that you have attended. I think it was history classes that you have been attending. Please share your experiences of the history class, how that session has been, and the feedback. You would be aware of the norms. So please fill up those feedback sheets as well. Okay. Glaciers is basically, so from top of the mountain, a lot of ice and lot of snow keeps on accumulating. Slowly and steadily, they start rolling down these slopes, aided by the gravitational pull of attraction. And that slow movement of ice, that is known as glacier. Then we have a hill, a typical hill. Now, you will be able to distinguish it from a mountain. A mountain had a conical top, a very great height, a steep slope. Hill has neither of these. Hills will never be covered in snow. Hill will have a rounded top, lesser height, easy to climb. Okay? And then you will have another geomorphological feature that you will come across. That is what is referred to as a plateau. A plateau is a flat tableland like structure with a flat top, a steep slope. So that is a plateau, a flat tableland like structure. Okay. So that is all that we will basically be burdening you with today. Okay. And this was the first session of geomorphology, the first session of geography. Take it as a kind of an introductory session. We can take the case of one of the questions which was asked from this particular area. Let me see if we are able to crack this or not. So on 21st of June, I'll launch a poll for this very quickly. Let us see. On 21st of June, the sun does not set below the horizon at the Arctic Circle. Horizon is where you have the sky and the ground seeming to meet each other. So sun rises and sets at the horizon. So does not set below the horizon at the Arctic Circle, does not set below the horizon at the Antarctic Circle, shines vertically overhead at noon on the equator, shines vertically overhead at the Tropic of Capricorn. So, which of these is the correct answer? 21st of June. It is a solstice. Yes. Divyanshi, this is the question which has come from this particular area. Mansi, Shruti, Vivek, Manas, Lakshya, good. Akshita, good. Manikanda and Prashamsa, good. Ananya, good. Praful, pay attention to each and every day's class and session. That will be more than sufficient as of now. So good. A majority of you have given the correct answer in this case. So it does not set below the horizon at the Arctic Circle, meaning what? Meaning permanent day. Permanent daytime. to be observed in this particular case. Horizon means where does the sun rise from? When you observe the sunrise and the sunset, where do you think the sun rises from? You will suddenly observe the sun appearing in the sky. So it appears from the horizon, that meeting place of the sky and the earth that we observe, that is referred to as horizon. Look at the meaning in dictionary or any particular Google page, you will understand the meaning of horizon. Yes, that is correct. So here, that is your answer in this case. Does not set below the horizon at Antarctic Circle will be on December solstice, 21st December. Shines vertically overhead at equator. When will that be the case? When both the hemispheres receive equal sunlight. So that will be on equinox. Very good. And then shines vertically overhead at the Tropic of Capricorn. When does this happen? This happens when Tropic of Capricorn is facing the sun. And when is Tropic of Capricorn going to face the sun? 21st of December, winter solstice. Perfect. Okay. Yes, Janvi, you can. So that is where we'll restrict the session here for today. And I'll take a couple of questions and then we will end the session. We meet again tomorrow when we initiate about the discussion about the origin, the formation of the planet, how did it happen, and talk about the rocks, the internal structure of the planet, the sources of information that we have, and we go on to the portion of the theories. Okay. And then here, Sakshi, the next day starts at after 12 o'clock, then date is changed automatically by time. So there is no need to have a kind of a dateline. So all the places will have, how will they observe the kind of a date? I understand that by after 12, automatically the new date will start. But in terms of the timekeeping, for example, you would have observed in this particular image here plus 1, plus 2, plus 3, plus 4. So where will that end? Or will you have a kind of a continuation? So that is why to demarcate the difference between ahead and before, here also you would observe you have the IDL. Okay. Thank you, Tarun, for the kind words. I hope that the journey in itself is something which is fruitful, and I hope that at the end of it, I'm able to create some difference. Okay. And Uh, Priyanshu, I don't understand how the Earth is getting the speed to move around the Sun. Aided by the gravitational pull of attraction, and also you have the fact that at the very formation stage of the planet around 4.5 billion years back, you had multiple such collisions of many objects. Now, these collisions, when you have two objects colliding, oftentimes they end up converging. Why they will converge, we'll study tomorrow. But that provides a kind of a spin and also gives a speed. So it was in that process of formation where that speed was accumulated. Okay. Thank you for the kind words, everyone. And Russia is close to sunrise, or Japan. So ideally Russia is, but Japan has always been referred to as the land of the rising sun traditionally, and the portion of Russia which is closer to the sun has not been inhabited for a long period of time. Hence Japan has always been traditionally referred to as. Okay. Absolutely, Vivek. Yes. And right. Why does aphelion and perihelion not affect the seasons, but the Earth still does? Because that slight distance of or difference of 3 million, 4 million kilometers, that does not influence the amount of solar rays penetrating through the atmosphere significantly. It is the impact of the solar rays once they have entered the atmosphere which creates that difference in temperature. We'll study that in climatology, where we'll keep aphelion and perihelion in mind. Okay. Kambhapati, south pole of the moon is not significantly explored. So, because it does not experience much of the solar insolation, so it is one of those areas where it is expected that some amount of ice would be intact, lunar ice would be intact. That is what we are keen to explore. Okay. Yeah, Lakshya, we are not borrowing some minutes as Earth rotates. Is it being added later? That is the entire concept that you have of 28, 29 days and the fundamental of the leap year as well. Uh, Kush, there in diagram it is written 23 degree 26 minutes instead of 23 degree 30, because it is the precise location is taken, but you can consider any of them. Take 23 23 and a half degrees. Okay. Bhagya, if you are interested in geography as an option, why not? See, the optional portion that you have to choose based upon your interest, whether you are interested in it or not. Once you find out that you are interested or not, then open up the notification. Don't get swayed by what I say, what someone else in the market, or what your friend says. Open up the notification, look at the detailed syllabus of the optional, and only then take a meaningful and informed decision. So, with that, I will end the session here for today. I hope the session was fruitful for you. Till we meet again tomorrow, do take care of yourself, relax a bit, and see you again tomorrow. Take care of yourself. Goodbye. Thank you, and have a good night.